Hello, wonderful people of the internet. Steka, hey, how are you? I hope you're having a great day. Welcome back to another episode of Simuleos. I hope you guys are all having a wonderful day. And yeah, I think we can go ahead and hop into what we're doing today. Actually, before that, I kind of want to talk about how we got here and why we're going back to the fractal flame method. So, as you can see from the title, this is a episode. This is a stream on the fractal flame method. We covered the fractal flame method a long time ago, in an apartment far, far away. Well, not too far away, honestly. It's walking distance, but it was a significant distance away. I wouldn't want to walk. Anyway, the point is that we are going to be hopping into this for a very distinct reason. So let's open up Zernal PP, let's ramble for a bit, and then we'll get started. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. And I'll totally address it as soon as I see it in chat. I've got a feeling today's going to be a bit of a quiet day. Just because yesterday was kind of also a bit of a quiet day. Truth be told, because I took a few weeks off of streaming, I really need to, get that stream stamina up and running again and kind of do longer streams so people know that I'm streaming regularly and all that kind of stuff. And let's just talk about why we're back to this. Hey, Trash Talk, how are you? So yeah, let's hop into it. So yesterday I drew this plot. Let's just draw that plot. I'm blue today. Oh, neat. So we drew this plot yesterday. Let me draw it again over here, where we said every time I make a video, I always kind of try to figure out what the expected views are, and here is going to be views on this axis, versus the time it takes to make those videos. No writing stream. I haven't been able to do any writing in November at all. Like, I just haven't had time for it. So unfortunately today we're not going to be doing a writing stream. Sorry about that. Again, I want to get back to writing, but I just have no time. Which, I mean, it's unfortunate, right? Because, I want to be able to do writing every day, but I just, I tried it for a week, and the truth is it takes like an hour, half, 2 hours every day. And you can dedicate time to it, but it's hard, I've done some, but I don't have anything ready I feel comfortable sharing. That's also totally fair, I really wanted to do NaNoWriMo as well this year, but I'm not going to be able to. I just can't. It's too late. There's just a lot of things that I want to be able to do, and I just don't have time for them. And I think the truth is I need to start acknowledging that I only have a finite amount of time in the day, and if I want to get stuff done, I've really got to just hammer out things and make those things that I do well. Is that a sentence? Make the things that I do well. What? Anyway, you guys know what I'm trying to say. The point is I'm trying to say that everything that I make has to be at a sufficient level of quality. And that's kind of what I'm trying to hint at. In fact, that's what I'm talking about here. So as far as writing is concerned, I do have a goal. I really do have a goal to get back into writing, to do more writing and all this kind of stuff. But unfortunately, I'm going to have to put that off for another few months. I'll still write, a short story every week or so or something like that, just to kind of keep the creative writing juices flowing. But I won't be doing as much as I did before. I will start, however, doing more writing the moment I can start working on this project full time, which is something that I am definitely intending to do. Now, I know what you guys are thinking. You're looking at my viewership on Twitch, seeing as how I have, 10 viewers right now, and I'm super far from being able to turn this into a full-time career, but also it's just a matter of actually, hammering things out, doing things that no one's ever done before, and that type of thing. So let's go here. Let me go ahead and draw a line right here down the center. And also, just for the record, this is in log scale, the views over here. So, like, for example, this could be, 10, and this could be 100, and this could be 1,000, and this could be, 10,000 or something like that, then 100,000, whatever. So the idea here is every time I make a video, I try to think about what the expected views are on that video. And usually most of my videos are around this range over here, right? So they hit here, and you should be expected to spend a certain amount of time to get videos of that quality, right? Now, for me in particular, I'm usually spending way, way, way more time to get these views, right, than you would expect based on this curve, right? I'm all the way over here or something like that. Now, ideally, what I want is to spend basically the same amount of time but bump myself up to the actual, the views that you would expect to have for someone spending that amount of time on a video. And so after having thought about this and thinking about things that we could do, I did have a video that I was going to make, and I'd been thinking about it, and you guys know about it because I was doing it last week on stream, about why left-handed people tend to die younger. And that would be over here. It doesn't take very much time, but the expected view count is, probably the same, if not higher, than my normal videos. The issue with that is I just don't feel comfortable making videos that don't take a lot of effort. I don't feel comfortable making videos that people could just, that anyone could make, and that's kind of where I'm at. I was unhappy with that video because even though it was fine, and honestly, not a single person who would watch that video would look at that video and think it's of lower quality. In fact, a lot of people would watch the video after I made it and think, wow, that was a genuinely good, understandable video from this guy. I quite like it even more than his normal content. Some people would see this video as higher quality, but for me in particular, based on the content that I like and the content that I want to put out, it would be significantly lower quality, and I'm not willing to lower the bar of my videos just yet. Maybe sometime in the future, I'm willing to do that, but not right now. Not with the viewership that I have. I still have a stable job and everything, so worst comes to worst, I can just rely on that. So what are we doing instead? Well, I thought of a lot of different things, right? As I said last Sunday, I spent the whole day doing nothing but brainstorming ideas and thinking about ways in which I could make content that really does hit this mark up here. That's, high quality, but still takes just about the same amount of time as my normal content. I'm going to start thinking about it more and more, and I got a bunch of ideas, one of which I actually want to show you guys over here because I'm still going to make this video, just not now. So here, for example, is a Mori effect book. I just want to look at the video, but you can kind of see it over here, right? Can I just view image maybe? Okay, let me make this bigger. So, right, there's this thing that's called the Mori effect. It's kind of related to, what is it called? There's a Nyquist Theorem is what it's called. It's kind of related to that, in that depending on how you perceive an image, like depending on kind of the filter by which you see the image, your brain will kind of connect dots to see like one fluid image, even if you have like bars of stuff surrounding, on top of it. So if you look over here, you'll see that we have all of these like squiggly lines and everything. And essentially what they've done is they have an animation that is underneath these bars. And as they move the bars, essentially it just moves frame by frame, and allows for your brain to create a connected image, creating this this kind of animation effect, right? Now, the truth is, a lot of people have done these before, right? So when I was thinking about what we could do that other people have not done before, I realized that there's actually a lot of axes here that people don't usually take into account. For example, this is just a linear motion. Well, you have linear in X and Y. In principle, you also have Z. And I'll get to that later. I was thinking about 3D Mori effects and all that kind of stuff, but I didn't get far enough to make that, like a real thing. And then you also have rotation, and you also have different colors that you could tinker around with and all this kind of stuff. So you've got like 8 degrees of freedom. How many is that? X, Y, Z. Well, let's just say X and Y. Those are 2 degrees of freedom for each, so that's 4 degrees of freedom. Rotation, that's 2 extra degrees of freedom. And then R, G, and B, and then also scale, in and out. So this is like, how many is that? That's 10 degrees of freedom or something like that. And here we're only using 1, essentially 2, because you can go back and forth. So I was thinking, let's make like the coolest animation we possibly can with this Mori effect. And in fact, I had a lot of like designs sketched up in order to like build an apparatus that would allow for us to utilize as many degrees of freedom as we could. That is to say, all those 10 degrees of freedom that I said before: color, linear motion, rotation, and potentially scale, although I wasn't quite sure how to get scale in there, all in one device that would then project the Mori effect onto like a wall or something. I had like big plans for this. And I still have ideas of how to work that all together. But after thinking about it a lot longer, I realized this is going to take significantly longer than I thought, just to come up with the actual, like, figure out all the intricacies of this one. So I'm putting this one on the back burner for now, but we will come back to it because it's super cool. I've got a number of other videos that I want to make, like one about how to think about two things at the same time. It's something that I trained myself to do when I was younger. I'm out of practice now, but I think if I just keep practicing for maybe a month, I could get it back. Also being ambidextrous and things like this. There's a lot of little things that I want to work on that I'm thinking about just making videos on that will take a lot of time and effort on my part, but I think will create videos that I think a lot of people are pretty interested in watching. So what are we doing today? Today we're going back to a video topic that we covered a long time ago, and that is the fractal flame method. Let me just go here and type in fractal flame, and let's talk about this. So we stopped doing the fractal flame method because, quite frankly, I got sick. I wasn't able to stream, and then I had to move back up to Boston. After moving back up to Boston, I spent literally all of my time focusing on this the course that we had to teach. So I wasn't really able to spend any time doing online activities, which made it so this particular topic got left in the back burner. I want to bring it back up, and I want to finish it, because there's a lot of topics that we want to cover that are important so that we can get the fractal flame working as we want it to work. Now, there is an additional step to the fractal flame method that no one has done before, and I think it might be genuinely new research that we will hop onto in the near-ish future. But for now, I just want to get a fractal flame method working. So today is going to be focused on kind of refreshing ourselves on where we were before, looking at some of the previous fractal flames that we have, seeing what we can do to make it better, see what we need to do to update the algorithm archive to make it so people can understand it better. If I remember correctly, we kind of got stuck on convolutions before, which, to be fair, maybe I just don't. We need to think about it. The truth is, what I want to do from now on is, instead of making like these kind of deals where I do a slightly lower quality video to get the content out on time, I'm actually just going to put in more work to get the content out maybe a little bit later, but to make it even better than it was initially planned. So this is kind of the idea. So for the next week or two, we're going to continue working on the fractal flame method. And then, genuinely speaking, I think we do have some new research that we can do with the fractal flame method that will create, hopefully, some incredibly stunning visuals that I think will be, I think will be really cool. And that's kind of what I'm hoping to do. Big Grunts, thank you so much for following. Really appreciate it. Let me get some water before getting started, and then we will kind of highlight where we are with the fractal flame method, why we're there, and kind of where we're going to go with it. All this kind of stuff. Okay, so that's enough for ranting today. Let's go ahead and move over here. We'll probably get into another rant later. I mean, that's just the nature of the stream, right? We rant about everything, but that's okay. I need to set keybinds to do that, but the problem is Pavu control and Pulse Audio keeps getting my output devices confused all the time. So if I set a keybind, sometimes it's trying to move this keybind around or move the Scarlett Solo USB analog when all I really need is the headphones to move up and down. I don't know. I need to find a better way to do that. What OS do you use? I'm using Arch Linux. Can I just do OS here? Maybe? Yes, I'm using Arch Linux with OpenBox. So yeah, that's what I'm using. Okay, so let's talk about Fractal Flame. We're going to do a quick overview for those of you who have not seen this before, because again, it has been a long time since we did it before. And again, guys, I'm expecting today's stream to be relatively casual. We're not going to get the 100 viewers or whatever that we were getting a few weeks ago. I think at best we're going to reach maybe 30 or 40. So if you guys have any comments, questions, concerns, I'm almost certainly going to be able to keep up with chat today. So just let me know as we go about it, and I'll do my best to answer the questions as we cover them. Communist Smeagol, thank you. Hey, how are you? I hope you're having a great day. Okay, so let's go ahead and hop into the fractal flame method. Fractal flame. Okay, so the heart of the fractal flame method is actually another method known as the iterative function system, which we do have a chapter on in the algorithm archive. So let me go ahead and give you that right now. Iterative function systems here. They are here. Go ahead and take a look at that. I'm going to show you what these are by talking about one of the most famous iterative function systems known as the Sierpinski Triangle. Okay, so here's the idea. We're going to create 3 points. Army Sim, thank you so much for following. Really appreciate it. So I'm going to create 3 points. I'm going to have A over here, B, which will be blue up here, and C, which will be green over here. And then I'm going to create 3 different functions. Function 1 will take whatever your point's location, we'll say that's P, and it will return P plus A over 2. That is to say, if you give it some sort of points location, it will return the midpoint between that point and A over here. Now, function 2 will do the same with B. So you reading some sort of point is going to be P plus B over 2. And function 3 is going to take in a point, and it will be equal to P plus C over 2. Okay, so the easiest way to think about iterative function systems is to imagine A, B, and C all generating 3 children, and these 3 children moving according to these functions. So that is to say that A will generate 3 children. One will stay where A is, another will move halfway towards B, another will move halfway towards C. B generates 3 children, one moves halfway towards A, another moves halfway towards C, and C generates 3 children, and they move into these spaces over here. Now those children then create more children. So this guy has one that moves halfway towards A, the next one halfway towards B, and the next one halfway towards C. This one creates 3 children halfway towards A, B, and C, and this one creates 3 children halfway towards B, A, and C. And essentially, as these children start generating more and more children, you eventually will start to see some sort of pattern. And I'm just going to draw it here and just say that it will keep growing in a similar manner. So this is the Sierpinski triangle. And essentially, if you keep going, you'll create triangles within triangles to create your Sierpinski structure. I've got an animation of this that I will show later. I think I'm going to have it as the animation that we're showing in the upper left-hand corner while we're doing the visualizations. But this is the heart of the iterative function system. Right, and this is also the heart of the fractal flame method. So the idea here is, what if we have, instead of this set of functions, another set of functions that does another thing? I don't know what it does, but it does something else, right? Each of these sets of functions will be called a flame, and the idea with the fractal flame method is that if you combine all of these different function sets, all of these different fractal flames, you get a fractal fire, and that fractal fire is whatever the visualization looks like at the end. It's a combination of all these functions put together. So for example, if we look at these fractal flames over here, this is a combination of a bunch of different like rotation functions and stuff like that, all of which come together to form this image. And we have color and motion blur and all this other stuff that we have to kind of consider. And that's where we kind of left off. So we had the idea of motion blur, but honestly, there's a lot of things that we want to talk about that we just didn't get to. Like, for example, these fractal flames are in principle animated, but you don't really see too many animated fractal flames, which is kind of a bummer because the fractal flame method is in principle animated. So we've got a bunch of things that we need to do to make it so our code can be animated. It does have like really cool visualizations and stuff like that. And yeah, it should create like really interesting visualizations. Again, though, what I'm most interested in isn't necessarily the fractal flame method, but what we're going to do with the fractal flame method. And we'll talk about that when we get there. Also, is this a tutorial on the fractal flame method? I didn't realize. See, here's the thing. All the tutorials are like not real tutorials, right? Let's see. I found the tutorials for Visions of Chaos. Anyway. So we're going to put this in the algorithm archive, and we're going to see what we can do with it. So, like I said before, let me go ahead and show you that visualization I was talking about before with the iterative function systems. And yeah, so I'm going to cd into projects, algorithm archive. What am I looking for here? Contents, IFS, ls here, cd into resources, ls, and then I should have, oh, actually, you know what? Maybe cd into projects, simuleos, fractal, ls here, and let me see, ls star.mp4. I know you guys can't see this, but give me just a second. I don't have any mp4 files. So what did I do with my fractal visualizations? I feel like they should be here somewhere, but also like I feel like I'm not seeing them. Okay, well, let me make this bigger, huge for now. And let me see if I can find that animation really quick. Sorry about that. Where would I have put it? Probably in my videos. CD videos. What am I doing with my life? 1 second. CD videos, and then I want to go into probably algorithm archive, then iterative function systems, ls here. And I should have some videos in here. MP3, images, video.blend, Sierpinski chaos, Sierpinski Hutchinson, that's what I'm looking for. So if I do MPV, Sierpinski Hutchinson.mp4, This is the visualization I was showing you guys before, where we have A, B, and C all being generated, and then D, E, and F being those kids of A, B, and C, and all of these guys then generate children, and they move like this. And then those children generate children, and those children generate children, and more children, and more children, and more children, until eventually you see the Sierpinski triangle form. So that was a visualization, and we'll have that visualization showing in the upper left-hand corner from there. So let's go ahead, Control-C here, make this a little bit, I guess, default. And now we're going to move that down here and have that playing. So loop 0. Okay, so we're going to have that just playing in the upper corner, something like that. Move this down, and I think we can go ahead and get started with the code. So there was a question, what terminal do you use? I use actually just Xterm, which is like the most basic terminal that you can get. And the reason I use Xterm is actually because I think I have L6 installed. I do. Let me cd into, project Simuleos, ls here. And then let me do cd into Fractal, ls. There's a couple reasons I use Xterm. One is that I actually really like bitmap fonts, and I am a big fan of just bitmap fonts. I think they look really good. The other reason is image to Sixel, fractal.png. Oh, that was a bad image. ls_.png. What else do we have here? Oh, I just have fractal.png. ls cd. I don't have any visualizations here. So let's go back to another directory where I actually do have some visualizations here. CD into hard. No, oh crap. Yeah, okay, because I burned my hard drives. I don't have any actual visualizations. So let's go into videos. Well, okay, yeah, videos then. Algorithm archive, iterative function systems, ls here. Do I have any videos, any images here? CD into images, ls here. And I should have a thumbnail. So if I just do img to Sixel thumb.png, it will show the thumb L6. So it should show all of the video images here. So these are actual images being displayed in the terminal, right? Which I think is really cool. So there's actually a lot of cool things that we can do with this. I mean, I guess if I just like download a GIF, I can show you why it's so cool, because you can just L6 a GIF and it's like an actual visualization showing in your terminal. Again, before I burned my hard drives, I had a lot of commands to do that, but I don't have those commands anymore. That's okay, I guess. Let me see. I mean, I guess I could just find a random GIF. But that's okay. It doesn't really matter too much. The point is, I like Sixel because it allows for you to very quickly look at the images and stuff as output. So cd into project Simuleos, Fractal here, ls here. And let's just poke around, see where we're at. So let's talk about what we know. So let's do journal, new page before. Hey, Arsav, how are you? I hope you're having a great day. So where are we? I can't imagine these features are Xterm exclusive, but maybe I'm wrong. Yeah, so both features are Xterm. Both of those features are Xterm exclusive because bitmap fonts are no longer supported by most terminals. That's the big reason why I'm using Xterm. And Sixel is, quite frankly, there's only a few terminals that are able to do these types of visualizations. Sixel was ported to Xterm, but there aren't too many other terminals that can do that. There's like a Kitty terminal or something like that that uses a slightly different visualization format that allows for you to do the visualization you know, in a similar way to what I just showed, but quite frankly, there's no other terminal that can do that right now that's available on Linux. I think you can use like iTerm 2 for a Mac that might be able to do it, and I don't think there's a solution for Windows. So it is what it is. Also, iTerm 2 doesn't have the same bitmap fonts. Again, I'm a big fan of bitmap fonts. I think that they're really good. I hate the fact that people are moving away from them. I understand why, you know, in a world where we have infinite resolution on your monitor, obviously bitmap fonts don't work. At the same time, they look so much better than any type of vectorized font I've ever seen. So, you know, I will use them as long as I'm able to use them, and then I'll switch fonts at that point. Okay, so what do we know? One, we know that the fractal flame method, I'm just going to annotate that as FF, that we wrote a few months ago, does not work right. I left it in a non-working state. Two, we know that we got stuck on convolutions last time, which were something that we needed specifically for was something that we needed specifically for the motion blur and stuff like that. And 3, we still have yet to write the chapter and stuff like that, and do some tests. So there's a lot of stuff like that. Now, we also know that there is a library available called Flam 3, which does flames for you. And so in principle, we can test whether our code's working based on the Flam 3 package. But let's get some code that's actually outputting some interesting results. And then we're going to come back to Flam 3. I'm wondering if it's working through WSL on Windows. I don't think it works on WSL. Like, I mean, maybe it does. I don't know. So let me do Sixel. And we should have, here it is. And then we should be able to do supported, I think it's supported terminals should show you. Yeah, terminal requirements. Here are all the terminal requirements. So the terminals that can do this are the DEC VT series, DEC term, Kermit, ZStem, WRQ reflection, RLogin, which is a Japanese terminal emulator, ML term, which is similar to Xterm, and then Xterm once you've enabled Sixel graphics on building. Again, there are other ones here, the Mac term, Wes term, iTerm 2, again, over 3.00, simple terminal Sixel, or what, suckless terminal, I think, Sixel, and a bunch of other ones. In fact, actually, there seems to be more than there were available last time. I was considering using the suckless terminal for a bit. I just didn't get to it. Also, toy term seems interesting, but again, I'm happy enough with Xterm. It's relatively fine. The only problem I have with Xterm is Unicode support, and since I've been doing a lot of Julia development, there's been a lot of Unicode that I need to support. So, but I hate that people are like, I don't like using Unicode in code. I think it's bad practice, because anytime that you're going to use Unicode, you're probably going to be using that Unicode to signify like a mathematical variable, and 9 times out of 10, math is like, the reason I like reading code over math is because, quite frankly, you can read code. Math is impossible unless you have text to go with it. And, that means that you have to have comments or something in the code explaining that, your theta here means an angle and not a temperature, because it could mean temperature in some, in some regards and stuff like that. Anyway, I'm kind of rambling a bit. Ella's here. So what do we have here? I've got a few things here, and I'm just going to kind of refresh my memory on what we have. So we've got the iterative function system, ifs.jl, and if I remember correctly, this is the main thing that we're doing here for the fractal flame. So let me look at flame. Yeah, so we have functions for fractal flames, and we have linear, hard, all this kind of stuff. So I think what I'm going to do is mess around with what we have here, and see if I can get an image that looks okay out, and then we'll go from there. So CD projects, Simuleos, Fractal over here, Julia, and then what I'm going to do is I'm actually going to create a Julia package that will allow me to do some quicker debugging and stuff like that. Now, like always, when I develop packages, I tend to do all of my development on a special development branch, which is to say there's going to be nothing pushed to master for a very long time. I just don't like pushing to master until I have a somewhat completed project, because the only things that, okay, so a lot of times people will go to my projects and they're like, yo dog, I don't see anything on in your code. And it's like, yeah, that's because it's all in a development branch. Because in my opinion, the only thing worse than people going to your code base and saying, I can't figure out how to run it because it's all in a development branch. The only thing worse than that is people going to your code base and saying, it's broken for me. And it's like, well, yeah, of course it's broken for you because I was using master as the development branch. So anyway, that's kind of another rant. I should stop ranting. Okay. So again, my first goal is just to get something that kind of works here. And then my second goal will be to, kind of go through the paper that we have for the fractal flame method and make sure that goal 1, get something that outputs something. Goal 2, turn this into a Julia package. Goal 3, make sure that the code that we have is somewhat reminiscent of the paper that we have associated with this, the fractal flame method as well. So that's kind of where we're at. Also, I just realized I did a huge change to this code not too long before. Dang, okay, I'm gonna be honest. I am completely lost looking at this code because it's been such a long time since I looked at it before. So let me just run this and see what happens. So we're gonna do include abstractions for, no, that's not what I'm gonna include. I just wanted to include ifs.jl, and see what this does. On the other hand, UTF-8 support is great for languages with non-Latin alphabet. That's true as well. I do 100% agree with that. But the truth is, most of those are already supported by Xterm. I can, like, here, let me just write and quit. Like, I can write in Japanese just fine. Hihihihi. Oh, chotto mate. Hihihihi. And then, wait a minute. This doesn't work on that scale. Does it only work on the default scale? It only works on the default scale. So that's my fault. I don't really understand why that only works on the default scale. But whatever. It's okay. So let's open this up again, and let me see what I just ran. I'm going to... I'm still in Japanese mode. Okay. So it looks like I ran pixels is equal to flame, and then I wrote the image pixels. So I think I should be able to open up Mirage, Fractal.png, and I think this is just going to be like a single dot at the center of the screen or something like that. Yeah, that is because I am dumb, and it has been a significantly long... This is like a little red dot. This code's not working right now. We have to fix it. You speak Japanese? A little bit of Japanese. So I lived in Japan for 5 years or so when I was getting my PhD at the Okinawa Institute of Science and Technology. And my girlfriend is Japanese. I want to learn more Japanese. I just don't have time. Obviously, at some point, I need to learn a lot more if I want to interact with her family and stuff. So it's just a lot of... I need to learn more. I intend to be learning more. Again, it's one of those things, as soon as I can start working on this project as like a full-time thing, which, again, at this point, is still a whiles away because I keep getting distracted with work. But, you know, once I can do that, there's a lot of things that I then have time for, like learning Japanese, writing my novels again, all this kind of stuff, which right now I don't have time for when I'm working 80 hours a week for MIT, and then I'm doing an additional like 20 hours a week, stuff from here. Watch Ushijima the Loan Shark TV show. I've never seen it. Sorry about that. Okay, so this code doesn't work. Japan looks messed up. There are certainly places, like, it's my opinion that if you're looking at a country, you can always paint a country in a bad light. Like, you know, look at the US, for example. Okay, maybe that's a bad example because there is actually a lot of, like, crappy stuff going on in the US. But also, I will say that the outside perspective of people they meet that are from America, like Americans, for example, they typically see Americans as polite, jovial people. Like, the way I see it is, once you get to know the people, usually it's fine, right? I guess my point is, you can always take a country and you can always paint it in a light that makes it seem like really, really bad, no matter what you do. And I feel like Japan is one of those countries that I personally didn't have a problem with, but I do know a lot of people who did. And so for me, Japan was like nearly perfect. Specifically, OIST, the Okinawa Institute of Science and Technology, 10 out of 10, best university I could have gone to, really happy going there. However, I will 100% admit that there are, like my girlfriend, for example, wants to leave Japan and never wants to go back because the work culture specifically for Japanese people is pretty rough. So, you know, let me see what we can do here. I am completely lost here. So I think, let me just kind of recreate what we're doing here. And I know that since I'm lost, I'm pretty sure everyone else is lost as well. So let me just read through this function and see what we're trying to do here. So the first thing we do is we grab a random point. This is going to be random times scale x times 0.5 minus 1. So what is scale x? What are we reading in here? So scale x looks like it's 4.0 and scale y is also 4.0. Cool. So let's just go up flame here. Okay. So that means we're on like a 4 by 4 grid or something like that. Well, it's -2 to +2. Take a look at our image here. And actually, this one's a bit more interesting in some sense. If we scroll in here and we go down a little bit, we'll see that we have like a line here. I'm not exactly sure where that line comes from. So let's just mess around and let's get something that looks interesting, and then we go from there. The glass is always greener on the other side of the fence. I'm pretty sure you mean grass, but yeah, I know that also. I feel like that's, how do I put this? A lot of people, like for example, getting a PhD is not particularly good, you know? It takes a lot of time, and honestly, it costs a lot of money. Even if you're getting paid to do the PhD, generally, if you're able to get a PhD, you can get a better engineering job that will pay you more money, right? It's a stressful time, and I know a lot of people that didn't deal with it very well. And this whole idea of the grass is always greener on the other side, that really does, resonate with, I think, a lot of people that I know from grad school. I don't really know how many people that shout when things are good. Aside from victory, the world is really mixed up. But it doesn't mean the majority of people are doomed to be bad. I guess you could claim the misnomer of common sense here, but some people really do not get this and talk so much out of their butt. Yeah, I guess I agree with that. The glass is always tastier on the other side of the beach. What? I must say that the title game is on point. Thanks, Trash Talk. Appreciate it. Yeah, I was thinking about, I don't know. I have no idea. But actually, now that I think about it, maybe it's insensitive because I don't know if California is still suffering from forest fires or not. Okay, so here we have a set of pixels here, and we're saying that the pixel is going to be 0, 0, color 0, 0, 0, 0 for I is equal to 1 to resolution X, and J is equal to 1 to resolution Y. So we're just setting a whole bunch of blank pixels. And then we're saying that our pixel file is just going to be called pixels.dat. Okay. Now, I didn't realize I was outputting the pixels. Now we have color is just going to be zeros of 3. We're just pre-initializing it. And then we have a post and pre-transformation. The idea here is that we take all the pixels, which are going to be... Wait a minute. We have a point. So we take all the points before we turn them into pixels, and we do some sort of transformation to them. In this case, I'm not transforming them at all, but in some cases you might want to rotate all the pixels or expand them or something like that. We'll talk about that later. Then we do an affine transformation on the pre-transformation. We say R&D is equal to random. We say R is going to be equal to the square root of point.x plus point.y. So that's going to be your R value. Just like, again, it's x squared plus y squared is equal to r squared. And we say if the absolute value of r is less than 0.001. So this is just making so r can't be 0. This is specifically for certain functions that we don't really have to worry about. We say the final point, which is the point after like all of the function selection and stuff like that, is just going to be able to point. We do point is equal to heart of point. I think maybe I need to do final point here. No, wait, what? I don't understand what my logic was here. This is just some bad code design. Again, this is all work in progress type of stuff. So I think this should be fine. And then we blend all the colors. Let me try commenting this out and see if maybe this broke the code or something. So let's go here and there and write this, and now let's just include and see what we got here. This compliment was brought to you by Compliment Talk. Thanks, Compliment Talk. Are you going to factorialize this Serpenti? I don't know what you mean by that, so probably not. Old newbie, thank you so much for following. Really appreciate it. But my bad. Yeah, sorry. I tend to try not to curse, at least when I'm reading comments aloud. I also tend to try not to curse in general, but that doesn't mean you guys can't in chat. I just try not to. Fractal.png. This has nothing in it. It's just a blank image. So cool. Let me try modifying the scale a bit, maybe. So let's just try one by one. Let's do one here. Write this. Go over here. Include. Okay. So right now what I'm doing is I'm generating a bunch of random points. So I would expect to see a bunch of random points, but I'm not. And so that says to me that I'm doing something really dumb here. So let's try actually blending the colors, because I'm pretty sure that's why it wasn't working. Okay, write this, DD there. Try this one more time, include. Okay, it seems to be doing something this time. Mirage. No, we don't see anything. Okay. This is going to be a bit of a rough stream where we're just not going to see anything for a long time. Then maybe we will. Okay, there's such a wide range of possibilities, and I sometimes choose the worst. Feel for you. Yeah, so let me, let's see. So what do we have here? I don't think, so this is doing a log scale. Let me comment out the log scale and see if maybe that's why we don't see anything. Write this, go over here, and we're going to include and see what the image looks like. Again, today's stream is just me trying to get something that works, and right now I have nothing. This code was working for a significant amount of time, and then I broke it in a refactor a few months ago, and then I just didn't come back to it because, again, I had to go. I got sick. I had to move to Boston, and it's been 3 months now since I looked at it. So this stream is going to be a bit rough. We're gonna have to. In fact, I'm thinking about maybe just rewriting this whole thing from scratch, because maybe that's what I do. maybe I just rewrite this whole thing from scratch. Because right now I've got a feeling that, yeah, I've got a feeling that this whole thing is just not going to work. So let's just do that, and let's screw the rules. Let's just go. So we're going to cd new projects, and what I'm going to do is go over here to github.com and create a new project. And we're just going to go from the paper, rewrite everything from scratch, and go. Because right now I think it's going to take longer to. We're going to have to understand everything from the bottom up anyway, so we might as well do it now. I'm going to go to new repository. And what should we call this? I'm going to call it flameify.jl. I guess. Nothing works. The only way is up, I guess. But also, like, okay, so flameify will create fractal flames. I guess we could call it fractalize, fractal flame, frame. All right, what can we call this guy? It is a fractal flame implementation in Julia. It's going to do more than that, so I'm trying to think about that. I do kind of want an if-I at the end because of where I know this is going to go. So f-flame, lattice. Oh yeah, maybe f-flame, f-flameify. F-flameify. It's a dumb name, but maybe we just go with it. And we're just going to say fractal flame implementation in Julia. Implementation in Julia. And let's grab a link to the paper. Fractal flame method. Sure. Okay. And we should get a paper right here, I think. No, this isn't the PDF I normally grab, but maybe it's okay. Maybe if I just do fractal flame PDF. Fractal flame algorithm. Yeah, this is the one I was looking for. So we're going to grab this and paste that over here. Here we go. Okay, so now we have the URL. I'm going to add a README, add a gitignore, and the gitignore will start with a Julia base. And then the license here is going to be MIT license. Okay. That should all be fine. I still don't like the name here, flameify, but whatever, it's fine. Let's go ahead and create the repository, and let's just go. And then we're going to open up the paper, and we're just going to start going one step at a time. So let's grab this guy. Get the GitHub repo. And now we're just going to do git clone this. Okay. Yep. Okay. So now let's go over here to Julia. Now I always forget how to do this. CD projects, flameify. Okay, always forget how to do this. Julia -- maybe. And then I do generate flameify. Okay, so now if I do ls here, cd into flameify. Okay, I have another directory, ls flameify. Okay, I need to bring that down one directory, so let's just cp-r sorry about that. Flameify star here. Okay, ls here, and now let's just remove -r flameify. Okay, so what I just did here was I created the package flameify, and then I took the project.toml and everything that we need so that we can instantiate all the packages and everything that we need down one directory. So now we should have in the source directory here a single file that's flameify.jl. So before I go any further, I'm going to do git checkout -b, and I'm going to create development branch. So we're on the development branch now, and let's go ahead and cd in or open up the source directory, vi source and flameify.jl. So now if I go over here, we control D and we do Julia -- we should open up the project, and now I want to do add revise. Okay. And then after adding revise, I'm just going to check to make sure that the package was generated appropriately and everything. I'm then going to do using flameify. Did that work? Oh, I'm sorry. I'm using flameify. Okay, so now we're able to pre-compile, and we should just have the greet command. So if we run greet, maybe flameify.greet. Yeah, okay, this will work. Then we have hello world. Perfect. Okay, so the package is working okay. Again, guys, it's gonna be a long day. I will probably be streaming for another 4 hours, and we're just going to slowly but surely build up the code, probably starting with a simple iterative function systems implementation, and then going from there. So where do we go? Hey, Amaris, how are you? I hope you're having a great day. Let me get some water. Hey, iCare, how are you? I feel like it's been ages since I've seen you, iCare. I hope you're having a great day. I realize that probably part of that is just because I'm streaming at a time that doesn't work for people in Europe or something. But yeah, how have you been? Let me get some water. And again, guys, I do apologize if I'm a little bit out of it today. I'm just tired. TensorCat, hey, how are you? Thanks for following. Anyway, so let's go ahead and just get started here. So what do I know that we're going to need? I'm going to think about that really quick because I'm actually not sure. So probably what I'm going to do first is I'm going to open up a new file, which is going to be source, and I'm going to call it fractalflame.jl. Okay. And in here, we're just going to say, I don't think we need to create a new module yet. I think if we just use fflamify module, it should be fine. So let's just go ahead and create a quick function here. In fact, no. Okay. Let's think about this in a bit more detail, right? So what we know we're going to need is we know we're going to need a function list. So let's touch source, and then we know we're going to need a set of flames. So this is just going to be flames .jl, which is going to be the set of functions that we need. And then we're also going to touch source, and then I guess we're going to call, I could call it the method. I'm not really sure what to call it. So I'm just going to call it fractal flame. Fractal flame.jl. Okay, so we have the flames in one directory and then the fractal flame method in another directory. And again, the flames are just a set of functions. So in principle, I can recreate the Sierpinski triangle visualization before. So let's just try to do that cold turkey. Is that a phrase I can use here? Let's just try to do that. Get a Sierpinski triangle visualization as a first approximation and commit that as a simple skeleton of kind of what we're looking for here. So to do that, I'm going to have to go into vi source and then fflamify.jl, and I'm just going to include those two files. So include, what did I call them? Flames.jl, and then I believe also fractalflame.jl. Flava flame, would be more sensational. What does flava mean? It's currently 10 p.m. in France, so that's okay. But yeah, 12 a.m. to start stream is hard to follow. Yeah, that's the issue, right? Like, it used to be a long time ago that I had a huge number of European followers, but ever since I came to the US, it's been harder and harder to stream at times that I could manage. In fact, it's been harder and harder to stream at all since I've come back to the US. And that's because, again, there were like 3 weeks in a row where I was like working 90 hours a week, and it was insane. Last week I was able to take a little bit of a breather, but even so, it was hardly a breather. It was like 60 hours of work instead of 90 hours of work. It's just rough, I've got a lot of work that I need to get done. And it just all feels kind of pointless, I don't know. I guess everyone who has a job probably feels the same way. So anyway, let's just keep going. Yank paste. And we're going to do fractal flame .jl. Okay, so this should be the two things that we have here. So what I'm going to do now is I'm going to go into vi source and flames.jl, and I'm going to create a quick function Sierpinski. And honestly, I can probably just use some sort of point P. Okay, so for this, we need to think about, what kind of abstractions we're going to need. We know that we're going to need some sort of point structure. And yeah, I think once we have the concept of a point, which I think honestly can just be a tuple, how about we just say point P and we don't worry about it. Point P. So we need the point, and then we also need A, B, and C locations. Okay, end here. And again, we're just going to recreate the Serpenti Triangle visualization. So in here, we're just going to return back another point. So this is going to say, okay, so now I need to just create a random integer. So how do I do that? Rand int, maybe? Does that exist? No, it doesn't. But can I do rand int? I can. So can I do rand int from 1 to 3? Can I do rand from 1 to 3? I can. Okay, great. So now I just need to figure out which point we're returning. So what I'm going to say is, there's probably a tricky way to do this as well. We have a point A, B, and C. In fact, maybe what I want to do is I want to read in a vector of points. So maybe we say triangle. Oh, how about we don't, okay, we'll just call this triangle points. But no, let's just call it shape points. Okay, just abstract it out a bit further, because in principle, this doesn't have to be a triangle. I mean, it does for Sierpinski, but you know, like, let's think about squares maybe, or pentagons, or octagons, you know, because you know what they say, or hexagons, right? Because hexagons are the bestagons, as they say. In Russia, it's already tomorrow. Yeah, it's also already tomorrow in Japan. My girlfriend already sent me a few messages today and stuff like that. Okay, work-life balance in the U.S. seems really broken. Work-life balance in the US, I don't think is super broken, but I will say work-life balance in academia is super broken. And people don't even realize how bad it is, because, you know, like, you are constantly working with people who are constantly working, right? And it's hard. It's hard to say at any given point that, you know, you're working too much, right? Because when you look at other people, they're working harder than you are, you know? If I work more than 40, 50 hours, I degenerate into a toddler. 90 hours is absurd. Yeah, those weeks were pretty rough. Legally, you can't work more than 40 hours in France, but if you have 2 jobs, you may work 60 hours a week, I think. Huh. That sounds... So the truth is, what I'm trying to do this month, and I've only really started this week, is just taking the time off. If there's a day off, like today is a holiday in the US, it's November 11th, which is Veterans Day. I took today off. This morning I read papers, and this afternoon, right now, I'm doing a stream for like 4 hours and stuff like that. And that's just how it is, you know? And over the weekend, I will be taking weekends off. Now, when I say I'm taking weekends off, and I say I'm taking time off, and I say I'm not working past 6 p.m. and all this kind of stuff, I mean that. But also, when I'm taking time off, what I actually mean is that I'm working on my online content. I essentially have to juggle 2 jobs right now, the second job being my online work. And that's just the only way I can get this to be a thing. Because honestly, you know, again, yesterday, I've consistently over the past week just thought about where I want to be in the next year, and I cannot see my job getting me there. So I need to just buckle down and get stuff done. I'm gonna be honest, work-life balance is kind of broken in the US of A, it seems. I've never had a job there, but so I can't say for certain. Yeah, so the truth is again, like speaking about Japanese culture, a lot of people say that Japanese work-life balance is also, I suppose you could say, equally broken. And that's probably true, but you know, that doesn't mean we shouldn't start fixing the US's problems just because other countries might have it worse. Okay, so in here, I guess what I want to do is I want to just create a random integer. So we're going to say point. Okay, so we have point, which we're reading in. And in the end, we're going to want to return, I think it's just going to be 0.5 times point, the point's location dot plus, and I guess I'm going to call it shape vertex is what I'm going to call it. And you guys are just going to have to deal with my bad naming here. Okay, so that's what we want to return. And in here, we're going to say shape vertex is going to be equal to shape points, which are, fine, I'll call them shape vertices or something. Okay, vertices. And then we're just going to do rand of int. Do I have to do int? Maybe I don't. Maybe I can just do 1 to length of shape vertices. Okay, and I think that'll do it. Okay, so the idea here is our shape vertex is going to be, that has to be square brackets. And that has to be square brackets of rand length of shape vertices. I think that'll do it. So this will give us the index for that particular point. So this should bring us halfway towards any of the shape vertices. So if we have 3 points, A, B, and C, this should bring us halfway towards any of those points. Also, I think I missed some notifications somehow. Maybe not. I'm not really sure. Anyway, that's okay. Don't you have some kind of choice function? This should... What do you mean choice function? Sorry about that. Hey, Lord Lycon, how are you? Oh, Lord Lycon, thank you so much for subscribing for 3 months. How are you? I hope you're having a great time. Let me go ahead and put a Simula cow, actually 3 Simula cows in chat. Anonymous Cheer, thank you so much for the bits. Appreciate it. 2, 3. I hope you guys are all having wonderful days. Of course, I really do appreciate the support. Thank you guys so much. And yeah, I'm trying. I will be streaming for at least another, I don't know, I'm going to say another 3 hours and 30 minutes today. I'm going to be streaming until 8 o'clock p.m. today. Then I'll take a break and we will see what we need to do from there. Like Python's random.choice. Oh yeah, we could do that, I guess, but it's okay. I think rand 1 to 3 is fine. Again, there's probably a more elegant way to do that, but I think for now it's okay. So now let's go to VI source, and we're going to do fractal flame.jl, and the very first thing I'm going to do is create a function for chaos game. Game, and in this we're going to take in n, which is going to be some sort of integer, which is the number of points that we're going to be simulating here. And then let's see, we want to have some sort of x and y range. Again, let's think about that. So we're going to say ranges or something like that, which is just going to be like the size of the box that we're working with. I think that's all we need. So let's go here and there. Okay, and for this, we're just going to try to recreate the Serpenti Triangle. So we should just be able to, again, we're just going to try to create that image we have up there in the upper left-hand corner. So we have to get some sort of x and y location. So I guess we're going to say, I'm going to say that for I is equal to 1 to n, which again is the number of points that we're working with here. And then we should have a set of points, so we should be able to just return back a set of points. So in here, we're going to say that points, which is going to be all the points, is going to be equal to, let me think about this, it should be, I do need to think about this really quick. So let's do a vector array of 2 by 10. What does this do? Maybe float 64? 2 by 10? And then maybe I need to do, I think I need to do it this way. 1 second, I'm trying to remember the function call. Let's do undef. I think it's 2 by 10 here. And then I need to do float 64 there. There we go. So I want the other way around, 10 by 2. Okay, that should be right. So let's go over here and we're going to say array, float 60. I could just use zeros. What am I doing here with the undefs? Not that it really matters, but you know. Arbebic, thank you so much for following. Really appreciate it. So here we're going to say zeros. Okay, chotomate, sumimasen. So here we're going to do zeros of 10 by 2. But it's not 10, it should be n by 2. And now we're going to say for 1 here, points of I is going to be equal to, and again, we're going to have some sort of random location. So it should just be Sierpinski. Random location, and then shape points. So we'll call it triangle points. Okay, and then we have to fill that in. What do we have here? That's just too good. Let me see. Up here, I missed the 1, but let me get that there. Wait, what is this? That's because it wasn't rigged. Yeah, okay, fair enough. Yeah, I'm not going to comment too much on US politics now, but it is a bit of a... It's a bit weird right now. I don't know. I don't know what to say exactly, except that, you know, Trump's weird. He's always been weird. I'm not a big fan of his rhetoric. Nor am I really a big fan of the Republican Party right now because they supported his rhetoric. But that's kind of where I'm at. I'm not going to... I really don't want to delve too much into politics. Sorry about that. Okay, I misspelled triangle, so let's go here. US politics is currently a mess, but whatever. Yeah, it is what it is, honestly. There isn't really much we can do about it. So in here, I'm just going to go ahead and set a set of triangle points. So we're going to say triangle points. What did I say? Points spelled that way is going to be equal to, and now we just need to give it an XY location. So let's do -1, -1. Oh, it doesn't really matter. -1. Sure, -1. And then the other point is going to be +1, -1. So 1, -1. And the last point is going to be, it doesn't matter. This doesn't have to be like a perfect triangle. So let's just say this is going to be at 0 in X and 1 in Y or something like that. Okay, sure. That should do for our triangle points here. We should be able to read that in to, we should be able to read that in. No, wait, we can't read that in exactly unless we do this. And this is not really good Julia syntax, but you know, I don't really care at this point. So let's do that and that. Again, we're just going to try to get something working and then we can worry about making it actually look correct later. Because this is just simple code. So here I'm just going to create our Sierpinski triangle. That should work. I think I need an extra comma there and an extra comma here. And also, I do think that these need to be specified as floats, so let me just make sure that they are being specified as floats. Okay, so we have the triangle points, we have the random location. We don't have the random location. So here we're going to say the random location is going to be equal to, and it should just be x and y, and the x and y are going to be, so the ranges, it will be like how big we want x and y. So it should be negative range 0.5 times range plus, and then it should be, I'm just going to say some rand, which is going to be between 0 and 1 times the range. Oh, I think I can just do that. I think that's all I need because the range is going to be an XY range. So we can do 0.5 dot times range and then plus rand, I suppose, of 2 dot times range. I think that'll do it. I'm just going to say that I'm happy Biden won. I don't have anything more to say about it. Hey, what are you doing today? So today we're actually looking back on some of the old Fractal Flame code that we had a while ago to generate like really cool visual effects via fractals. And we're just trying to basically build a package that does that from the ground up. And then from there, hopefully we can build it into even more interesting and cool things. Again, what we probably need to do is once we create a package that does this, we also need to create like a succinct bit of code that we can then put into the algorithm archive and stuff. Lots of work still to be done here, but you know, slowly but surely we're getting there. And that's really, you know, the only thing that matters. Okay. So is this going to run? We have Chaos Game. Maybe it runs. Who knows? I mean, does one really know any of this type of stuff does this work? What happens if I run Chaos Game? Does this exist? Let me do flameify.chaosgame. Does not exist. So let me do D Julia using revise. And now let's try to do using flameify. And then after this, we should be able to return the points, I believe. Here, let's do return points. Again, not commenting. I don't think this is the best written code, but it doesn't really matter. Using flameify. Seems to compile, so let's do chaos game. Game, and here we're going to read in, let's just do 1,000 or something, and then the ranges is going to be -2, 2 or something like that. Sure. Okay. Chaos game not defined. That's because it's probably flameify dot chaos game. Okay, error. No method matching times for float 64 type of range. Okay, that is probably because this should be ranges because I'm bad at naming. So let's do ranges there. Try that again. And see what happens. Now this should return a set of points that we then just need to plot. Cannot convert object of array float 64.1 to an object of type float 64. This is going to be on line 8. Okay, so points of I. This is because probably this is going to be points of I, points of J, right? So I probably want to do a dot equals here. Okay, and probably points of I is going to be the row index, right? So probably I colon is what I want. So let's try that. Okay, that seemed to return a set of points. So now let's just do add plots. Give it a second to do all the pre-compilation and all that kind of stuff. We'll see how that goes. And I should be able to hopefully plot Serpenti Triangle. So now we're going to try using plots. And again, hopefully this creates a Serpenti triangle that we can work on. Ergo93, thank you so much for following. Really appreciate it. And yeah, let me know if you guys have like cool ideas for videos and stuff like that, by the way. I'm always looking for new ideas. I've got a set of like, I think really, I don't want to say banger, but I really do think banger videos or whatever it's called, that I think are pretty cool. So I'm really looking forward to this next set of videos that I make on my channel. I'm really getting into it too. It's been actually years since I've really gotten into like wanting to make video content. In fact, last time I really wanted to make video content, I don't think any of those videos that I made are still on my channel, except for my exciting egg experiments videos. The rest of them were taken down. So let me just try plot of points. and see what this does. Points not defined. That's because I think I need to return them. So points is going to be equal to that. Okay, so now we have that. What happens if I just plot of points? I don't think this is going to work. That's not going to work at all, because it's going to read that as a, I don't know how that's going to read that, actually. Yeah, so that didn't work because it read that as two separate lines. So now we have to set them as one big line. Now I've completely forgotten how to do that. So we're gonna have to go from that. We're gonna have to figure that out. Hopa sauce, that's a nice animation. Yeah, so we made it a while ago for my YouTube video. Here, let's go here, YouTube. Let's see. I just thought about Blender. Wouldn't it be nice, a nice environment for your animations using the built-in Python interface? It'd be really useful for 3D, and all the video stuff is already there. Yeah, I use Blender all the time for 3D visualizations. If you go to my YouTube channel, which I just put a link on here, I would argue more than half of my visualizations I have all used Blender. So let's see. It was two different videos. So it was, let's see, the one video was iterated function systems. That's where the main visualization came from. And then the other one was how to make fractals with trees. Now, videos that I used Blender for, let's go to sort by most popular. Those were actually my most popular videos, I guess. So 1, 2, and 3, all of these guys use Blender for their visualizations with Python. And also Demons, Maxwell's Demon Experiment. That one also used Blender in the background. Okay, I was severely mistaken. I thought that over half my visualizations used Blender, but really it's like color quantization, Maxwell's Demon, Gaussian elimination. So 1, 2, 3, 4, 5, 6 that I'm seeing right now that use Blender. There might be one more, so maybe 7. But no, it's not over half. For some reason, I thought it was over half, but it's very far from that. It's like, at best, a fourth, because I don't have too many videos on my channel. And that's, you know, something that we should fix, but it takes time to fix. Okay. So I know I've done this before, so let's just write and quit. In fact, let me open up a new terminal and just hide it. So let's do huge over here, move this over there. And let me see where I last did this plotting. I know I've taken a two-dimensional array and turned it into something that I can plot. So cd into project, simuleos, L is here, and what do we have here? We have Nyquist. I feel like it might have been when we were doing Nyquist stuff, but I don't think that makes any sense. What I'm trying to do is take a 2D array and turn it into something I can plot. So where would I have done that last? We have affinity propagation. Hey, Supercuber, how are you? I'll check them out. Yeah, I mean, feel free to do so. Again, the stuff that we do for YouTube, I honestly think the visualizations we make are like some of the really good math visualizations. I'm not going to say that they're quite 3 blue 1 brown level, but I am going to say when we make visualizations, they turn out pretty well. I'm working on the Fractal Flame project. Sorry about that. I don't have a command for that. Okay, so we've archive Barnes, hut, complexity, computers, convolutions, domain coloring. Where would I have done this? Finite difference time domain, FFT, flood fill, Fourier challenge. Oh man, there were some good things in here. Every time I look at the set of directories that we have here, I'm like, man, there were some really cool things that we never actually made videos on. Transpose function, maybe? I don't think so. Maybe it was. The last time I did was with the fractal function. But that doesn't make any sense. Viral video. Oh, I know I can just plot this in new plot. Let's just plot it in new plot and not worry about it then. So let's go over here and let's just do add delimited files. There we go. And then we're just going to write that to a file, and we're just going to plot the file with new plot, and we're not going to use the basic Julia plotting because I don't really care that much. Okay, so I misspelled delimited. Yeah, I know. Delimited files. Is that right? Okay. So now if I do, I think is it right? DLM. And I don't remember the notation here, but I'm just going to say points.dat. And then we're just going to say points. See what happens. Seemed to work. So now if I run GNU plot and we plot points.dat, do we get a Serpenti triangle? We do not. That is very far from a Sierpinski triangle. But I suppose it's not so bad. Oh, I see I'm an idiot. Of course, it's an iterative thing. Why am I so dumb? We just did an affine transformation, or not that. I don't remember what we did, but I know what we did. I know how to fix it. Let's fix it. So if the random location is equal to that, and then we say the points of I is equal to this. So let's go ahead and just start a random location up here. And in fact, let's just say that our initial point is equal to that. That way we don't have to worry about that. So let's just say points of 1 colon is going to be dot equals this. And then here we're going to say for 2. And then in here we should be able to read in points of, oh, hello there. Let's try that one again. Should be points of I minus 1 colon. I need a comma there. Try this now, Control D. Let's see, I think if I just run the last points is flimify.chaos game, I write that out to file, then I run GNU plot and plot that. There we have our Serpenti triangle. Nice. Okay. Also, guys, I just realized Delphi, actually, I don't know, is it phi or phi? Anyway, I guess that's something else entirely. The question was, the discussion was brought up about transposes. I'm gonna be honest, I would love to go back and do more of like the distributed transpose stuff, like doing some of the like kind of more research oriented streams. But I haven't been able to do that in a while. One day, maybe we'll come back to it. XX Supercuber XX, thank you so much for following. Really appreciate it. I hope you're having a great day. I hope everyone's having a great day. You know, it's a day. Okay, so since we have something that's kind of sort of working, let's go ahead and commit this. So quit here, git status, git add. I think I can just do, let me go into the vi .git ignore. And let's also add in a .dat file down here. And I guess I'm just going to do this and say data files. And here is .dat. Okay, git status. Okay, git add dot, git status again. Okay, looks like we have everything added in. So let's do git commit -m, adding simple Sierpinski visualization. Okay, git push. Origin development. Okay, that's nice. We have something that's kind of working, and I'm relatively happy with that. Again, we don't have the plotting inbuilt. We had to use, GNU plot for that, but also we're not really going to be using the plotting developed in Julia, right? We're gonna use separate plotting functions and stuff. So let me get some more water. There's a bunch of things that we need to do. I think the next thing I want to do is actually create the function that will allow us to go from a set of points in some sort of two-dimensional space into an image of pixels. And I think that's the next thing that we're going to do. Plot transpose of points. Oh, maybe. I see what you meant. I misunderstood. I thought you were looking at the directory that we had from the Simuleos directory and noticed that there was a transpose directory because we did do some work with, a distributed transpose on GPUs and stuff like that. Unfortunately, it didn't go anywhere because I'm not going to, quite frankly, people are interested in different things and I never really get the chance to work on what I want to work on. I always have to work on what other people care about. So I ended up not being able to work on, work on the stuff I actually wanted to work on. Anyway, so I think the next thing I'm going to make is the ability to take an array and output it into a set of pixels. So to do that, I think we need to load in the images library. So let's just do Control D, and let's just add images. And I believe if we use images here, we should be able to have like a write function or something. I'm just kind of, again, worst case scenario, I can look at the old code that's all broken and stuff like that. And we can pick out all the pieces to the puzzle that we need. But I think for now, we're just going to kind of take it one step at a time. So let me go ahead and touch source. What are we going to call this? I think we're going to call it maybe make image or image tools maybe .jl. So let's go into vi source and flamify, and let's include that as well. In fact, maybe we don't need that. Maybe we only include it in the fractal flame. So let's just think about the functions that we need, and then we'll think about where we want to include these. Well, no, let's do it. So let's include, what do I call it? Image tools.jl. dt dot image tools.jl. Okay. You could use netpbm format. It's made to be easy to implement. Yeah, so as far as file formats are concerned, we're basically going to be outputting a PNG image. So we don't really need a file format for that. And also, like, I don't think there's anything easier to implement than a CSV file. And I think it's, like, that's what can be immediately plotted by GNU plot. So that's what we used. It's easy enough. But yeah, I've never actually done a netpbm file before. Usually I'm okay with some sort of, so usually if CSV doesn't work, what I typically do is I typically go all the way to HDF5 or netcdf or something like this. Maybe netpbm is similar to netcdf, I'm not really sure. Or JLD2 for Julia, kind of just depends. Okay, let me actually check something over here as well. Do I have quality options? I didn't even check that. It does look like I have quality options. Great. Okay, just had to check. Plotting using matplotlib. We could do that. I really don't like the plotting tools in Julia. It's one of the big shortcomings, I think, of the language. Okay, so let's go into the image tools. So VI source, image tools, using images. And what do we want to do here? I think we want to create a function that's just going to be called, a function which is just going to be called write image. Okay. And what this is going to do is it's going to take in a set of points, and it's also going to take in a set of ranges, the X and Y ranges that we need. In fact, do we even need that? The points are going to be an XY location. I think maybe we do. Yeah, I think maybe we do. Let's just keep going here and here. So my idea here is that I want to create a set of pixels. So in here, we're going to say pixels. Oh, we also need an image resolution in here. Resolution is going to be equal to just zeros of size resolution, which means resolution should be read in as a tuple, which is kind of a bit weird. Let me see if I can just do zeros. What happens if I just do 1, 2? Does that work? No, it doesn't. It needs to be a tuple of 1. Wait, does this work? Okay, so that does work. Can I convert an array to a tuple? How would I do that? Converting an array to a tuple, Julia. Oh, hello. Converting array to tuple, Julia. Let's see what we can find. Okay, keep dropping that. Array to tuple. Is it just tuple? Is that it? Tuple, 1, 2. Will that do it? Not quite. That's not what I want. I definitely can't do that one. So if we do tuple of this, that's not going to work. Yeah, of course that doesn't work. Okay. So what I'm looking for is tuple of 1, 5. Oh, there's a dot. Of course I can just splat it. That should do it. Okay, great. Great, great, great. So here we want to do tuple of, and we should be able to do ... there. Okay, so that should create our set of pixels, which is going to be like, I don't know, 1920 by 1080 or something like that. I don't really know. Okay, so now we have our set of pixels. And I guess what I want to do is I want to go through all the set of points. And I want to basically say if there is a value at that point, we then, like basically add 1 to that bin is essentially what we're doing here. So here we're just going to bin the pixels. So we're going to say bin the pixels. Okay, so how are we going to do this? For I is equal to 1 to size of points along the first dimension. Okay, and there. So that's going to be a set of points. All of these guys have an XY location, right? So if they all have an XY location, what we're trying to do now is we're going to try to convert that XY location to its closest pixel location, right? So the idea here is we have some sort of map. Let's see. So we have some sort of square here, and we have a bunch of points, and I'm going to draw the points in green, I guess, or blue. So we have all these points over here, right? And essentially what we have, draw lines, is a pixel map over here, something that looks like this. Forgive my crude line drawing skills in here. And what I'm trying to say is essentially, we need to find that this pixel, or this, oops, sorry, this object falls within this pixel. That's what we're trying to figure out. Now, I did do this in the other code. Maybe I just look at what we did with the other code for simplicity's sake. In fact, maybe that is what we do. Just to see how I did it and see if we can just optimize on that. So we're going to cd into projects, simuleos, ls here, cd into fractal, ls, and go into vi ifs.jl. Okay, so now we have some struct color. We'll deal with that in just a second. We have mixed color scale. Where's our right image? I'm sure I called it right image. Like I'm 90% sure. Okay, so here we said array of RGB, whatever. And we just said pixel P is going to be the array of pixels 2. So it's going to be a 2-dimensional array of pixels. And then we just said A of I is going to be the pixels of I. Oh, so I already created the pixels. Okay. So where do we get P from? So let's see, where do we call right image? Right image pixels. That means flame outputs pixels. So how do we do that then? So let's look for the top of flame, and let's see where we create the pixels. So again, there's our pixels set. That's okay. Pixel file is equal to that. Okay, so now if I is greater than 20, which I do think we need to do, we're going to say xval is going to equal to floor of int. Okay, so this is what we did. Sure, okay, that seems fine. So the scale xy is going to be the physical scale, whereas the resolution xy is going to be xy location, xy resolution. So we said it's going to be the floor, the integer version of the floor of the final point.x, so that's the final point's location, plus scale of x times 0.5. Okay, so I think we can actually just use this directly. So let's just take this, go over here, and let's paste it in there, and then we're going to modify it. So here, instead of going from 1 decisive points, we can just go from, we're going to say 10 decisive points. And in here, I'm actually going to change this. So we add in an optional argument saying point offset set is going to be equal to 10. And here it's just going to be point offset. Here, dd there. And I think I can dd here and do a 4x here. 4x. Okay, so here we have an x value and a y value, and we're saying the x value is going to be equal to the floor of int, and then the final point dot x. So here it should just be, where do we define the point? So here it should just be, I want to say points. Again, we're going to modify this in just a bit, but here it's going to be points of I1. I think that's going to be the x1, and then points of I2 for the y1. I2 for the y1 times scale x, scale y. So this is just going to be equal to the ranges of 1 and then ranges of 2. Okay, times 0.5, and this is going to be ranges of 1 and ranges of 2. And then ranges of 2. Okay, I'm wondering if I might be able to just like, yeah, let's think about this in a bit. So here we're going to do resolution of 1 and resolution of 2. 1, resolution of 2. I can probably put this all into one command, be it, let's say point, let's just leave it this way. I don't think we have to worry about it too much. So then this will give us all of our set of pixels. And we have pixels.value is going to be plus equal to 1, and pixels.color is going to be equal to some sort of mixed color. So this is where we're going to do all of our image manipulation stuff. Let's go ahead and create some sort of struct that is pixel. So in here we're going to do struct pixel, and in here we're going to have value, which is going to be of type float64. And then also we probably need some sort of color, which is going to be of type color. Yeah. Which is going to be of type color. I'm bad at naming these, so let's just worry about that later. Resolution 2, thank you for that. Okay, that was 3. Let's try 2. Okay, so we're going to do pixel.value plus 1. And so what I need to do now is I need to do another loop through here, and we just need to normalize. Yeah, we just need to normalize along 1. So let's go ahead and do a quick normalization function. In fact, okay, let's not have struct pixel for now. We're going to add this later. We know that we need that, but for now, let's just use float64. And let's just create like a simple heat map. And then we're going to come back and we're going to turn this into something better. So we're just going to do pixels dot val. So pixels plus equals 1. And that should be fine. And now I think all I need to do is normalize this. So what happens if I just normalize? Let's just do normalize. Okay. Is it using linear algebra? Maybe it's linear algebra. Norm. Okay, so let's do add linear algebra. And then we have to do using linear algebra, and we should get normalize available there. So let's do normalize of, and we're just going to do, oh, I don't know. Let's try ones of 10, maybe. See what that does? Normalize, not define. Ah, crap. Is it just norm? Of 1s, 10? Norm not defined. I'm using linear algebra, right? Did I forget to do using linear algebra? Maybe I did. Okay. That didn't really help. I think I want normalize here of 1s. Okay, so that made it so it's all 0.36. Is that what I want? Not necessarily. I want it to be that... Okay, so let's look for the max. Maximum of... I guess it's just going to be zeros. Well, 1s of 10. Okay, sure, that's fine. So now what we're going to do is this, and all we're going to say is return pixels dot divided by maximum of pixels. All right, so that should give us our image. In fact, we don't want to return it. I think we just want to write this out. So I think we just do write. I want to say it's the file name first, but I don't really remember. So let's do file name, pixels, and let's read that file name in as a function argument. Okay, in principle, this function should work. So let's control D, run Julia _ project. And also, I think this should be fine. So now we're going to run using revise again, and then using flamify. Okay, give this a second to build, make sure that everything works. And then we're going to try to write this to image, and then we should get an image of the Sierpinski triangle that we can then work with from there. So that's kind of the first step to the fractal flame method. So now we should be able to say points are going to be equal to that, and we should be able to just read everything in. So we should be able to write image. I guess it's flamify dot write image. Okay, and we need to read in the points, and then we need to read in the ranges, which I believe was -2, 2. And then we need the resolution, which is going to be, I don't know, 1920 by 1080. 1080, sure. Okay, and then we want the file name, which we're going to call check.png. In principle, that should run. Resolution X does not exist. Where is that being used? Ah, here it is. If the X value is less than ranges of 1. If resolution X, if X value, oh, I see, is less than, and this should be resolution of 1, this should be resolution of 2. Write that, go over here, try it one more time, and then hopefully that does something. We'll see. Again, it's kind of pre-compiling the images and everything. Attempt to access 1920 1080 array float at index 444. 1371. What is wrong with that image? What's wrong with that index? Is there something wrong with that index? I feel like there should be, but I can't quite figure out what it is. In write image, line 12. So pixels of y val, x val. Oh, it is y first. Okay, wait a minute. If y is first, then this should be 2 and this should be 1. One second, I need to think about this. I think I just got everything mixed up. So let's do 1, 2, and let's change this to x val, and this one to y val. Try that one more time. it output a number. I'm not exactly sure why, but let me just try opening up Mirage check.png. Okay. It didn't seem to do what I thought it would do. So did it write the image out? So let's go here and let's do print line, I guess. Wrote image. Did I misspell with check.png? No, I got that right. Okay. Let's go here to this. Wrote image. So it did get all the way through the function. And maybe every time we do this, we output the value that it's updating. So let's do print line xval, comma, new tab, and then yval, something like this. Write this, go over here, and let's try that. Okay, so we are outputting values. Okay, this seems fine. Maybe we can't do grayscale appropriately. So let's just try using this write file name thing, see if that's actually working, because maybe it's not. So let's say A is going to be equal to zeros of 100 by 100 or something. And then we're going to say A of, I'm just going to say 1 to 100. Well, let's do 1 to 10. And 1 to 10 are going to be dot equals to 1. 1 second. Dot equals to 1. Okay, so now the next thing, if I do A, we should see the top bit. All these guys are now 1s, which is exactly what we wanted to see. So what are we going to do next? So now we just want to write that out. So write check.png and then A. Okay, that seemed to do something. So now if we do mirage check.png, we again get an empty image. So here's the question. Let me do mirage check. Oh, it should just be check.png. Okay, it is an empty image. I'm not exactly sure why. Maybe it's because it doesn't like PNGs. So let's try something else. So let's try write check.jpg. And now let's try looking at mirage check.jpg. Also still a black image, which says to me that the write doesn't work here. So let me try... A is going to be equal to array of RGB, and we're going to say 100. Well, let's do 1000 by 1000. Doesn't really matter. And we're going to say these are all going to be undef. Sure. RGB not defined. Using images. Okay, great. So now we're going to say A is going to be equal to A of colon is going to be dot equals to RGB of, let's just do rand, something like that. RGB not defined. RBG, red, oh, RGB. Okay. So now let's just try writing that. So we're going to write check.jpg. Write is not supported on a non is, okay. Write is not, okay, that's good, that's good. So write is apparently not what I thought it was. I thought that write would write an image, but apparently I had that wrong. So let's go up here, write image, it's save. Why am I so dumb? That it ran, so I thought it was fine. So let's do save. Okay, now let's try using, what am I doing here? I'm gonna look for this guy. Okay, it's pre-compiling PNG files, so I am somewhat confident that we will get some sort of image out at the end here. And that is pretty good. So let's see what happens. So we have that. Let's run mirage. Check.png. We got an image. And if you look really closely, you can see a bunch of points. It's just our pixel resolution sucks. So let's try write image again here, and let's just try dropping that down there. And now let's try mirage check.png, and now you can see, whoa, look at that. Ah, that's so amazing. Okay, so our X and Y axes seem to be mixed up somehow. I guess. Actually, no, I don't fully understand. So our triangle starts drawing at from -1. What happens if we plot points in GNU plot again? So let's do right. There should be right DLM points.dat using delimited files. Let's try that again. Now let's just open up GNU plot and let's just plot points.dat. Okay, so it goes from -1 to 1, and then so it's -1, 1, 1. That should be what we're looking at. That's good. So why then, when we looked at the image, was it so cut off? So our scale should have been -2, 2. Maybe that's why. Control D. Try this again. Right. So let's just do 2, 2. See what that does. Now we're gonna do mirage-check.png. No, that did nothing. That did nothing at all. Okay, so if our image is from -2, like it should be from -1 to +1, -1 to +1. So we should see our triangle, but for some reason it's being cut off. And that is what I'm not sure about. So why would it be cut off? Well, let's just keep messing around with it. So we know that all these points are on the map, right? So that says to me that our x value and our y value are off a bit. It also says to me that, again, our x value and our y value are flipped, which is fine. So what I'm going to say is if we flip these around, so this is now going to be x value, and this is now going to be y value, and we change this so it's x value and y value, we should get a triangle that's the right way up, is my guess. So right image. Now let's take a look at mirage-check.png. It's not the right way up, but we do have a full triangle. Now, is that better or worse than what we had before? Not entirely sure. Yeah, I'm not entirely sure. Okay, so why is our triangle rotated is the question. The answer is because... Okay, so why is our triangle rotated? Okay, so we'll think about that in just a second. I'm going to take a quick break. I'll be back in just a minute. And then we can try to figure out why our triangle is rotated in our right image function. And then after that, I think, should we turn this into a test to make sure... I'm not sure how to turn this into a test exactly right now. Like a test just to make sure that we can output something. I suppose that's one thing. But we'll try to figure that out. Anyway, guys, I will be right back. Sorry about that. And then we can continue trying to figure out why our triangle is rotated and all that kind of stuff. We've still got another, looks to me like 3 hours or so in stream today. So plenty of time to mess things up and try to fix everything that we've broken. So yeah, I'll be right back, guys. Sorry about that. Okay, see you in a bit. Okay, I'm back. Give me just a second, and then I will put the screen back up. Right. Hello. I hope you guys are all having a wonderful day. We have about, again, another maybe 3 hours or so left in stream. A little bit less than that because it's currently 5:15, and I'll be leaving at 8. Let's go ahead and recap what we're doing right now because I think this is a good time to do that. It's been about 2 hours of streaming so far. And yeah, we'll go from there. Again, guys, I'm sorry that I'm a little bit tired today. I am trying to get, I'm just tired. I don't know why. I've just been tired for the past few weeks. Streaming helps me not be as tired, but even so, I'm still a little bit tired. So what exactly are we doing here right now? We are basically recreating a fractal flame generator. Now, what is a fractal flame? Oh, that's a very good question. Thank you so much for asking. It is a variation on the typical iterative function system method, which is what we have, what you'll see up here to generate our Sierpinski triangle. In order to create like even cooler visualizations. And so the idea here is that we want to use the fractal flame method in order to make really cool animations and visualizations and all this kind of stuff. So right now I'm creating a new package called Afflamify, and we just got started. So right now we're just doing the Serpenti Triangle visualization just to make sure that we can do normal iterative function system development. And then from there, we're going to try to make it even cooler. So again, we're just getting started. Right now, the only thing we have is the ability to make a single plot, which is this plot in here. Again, it is technically a Sierpinski triangle, although we have a few questions as to why the triangle is rotated 90 degrees. I wasn't expecting it to be rotated 90 degrees and stuff like that. So we're going to try to figure that out. For those of you guys who maybe don't know what an iterative function system is here, this visualization here, I think, gives us the best description of it. So the idea here is we start out with 3 points, A, B, and C, and we have 3 functions that basically take in any point and return back the midpoint between the point location that you read in and the point A, B, or C, right? So if we generate 3 new children, D, E, and F, and we have these 3 children generate new points, right? Generate new kids. And each one of these kids will move in a different direction, either towards A, B, or C. We can then, see that they all go off in their own directions like this. And then those will then go off in directions again and again and again. As long as the kids keep generating as long as the generations of children keep generating more and more kids, you'll eventually create the Serpenti triangle here. And the idea here is that the Sierpinski triangle is something known as an attractor. Its shape basically attracts all of the points from the function system, right? So that's kind of what we're doing right now. We're redoing this visualization in a chaos game fashion. And then from there, we'll start to add in everything that we need for the fractal flame method. So all we have right now is the ability to basically create points, have them go through a function system, and then we're writing that to image right now. That's all that is like step 0.01. We aren't even on step 1 yet. So I guess the hope for the end of today is that we can get to point 1. So this means we have basically all the structs that we need to just go ahead and start doing some sort of fractal flamey type of thing. And that's the hope. We'll see where we can get. Okay, so one thing that you did notice was that the fractal flame itself seemed to be rotated 90 degrees. Now, this is fairly typical, I would say, because the way that we read in the initial points. So let's think about this really quick. So GNU plot, when it plots something, so let's just go to GNU plot and let's plot a GNU plot. It assumes the first axis is X and the second axis is Y. Julia thinks the first axis is Y and the second axis is X. So because of that, we actually have a fundamentally different triangle that we're plotting, just because one should be rotated. So I think this is actually the correct result. We're expecting a rotated triangle to some extent. However, that doesn't make it any nicer, so I want to think about it a bit more, just to make sure we do have all these axes set correctly. So that's what we're going to do now. We're just going to take a look at these, make sure that this actually makes sense. So here we're going to say that our pixels is going to be a set of zeros, and it's going to be a tuple of the resolution that we're reading in, so like 1920 by 1080, whatever that happens to be. Then we're going to say for I is equal to the point offset, which is going to be, flipped axis makes it mirrored. No? Yeah, it should. I mean, I think that's what gives us our, I think that's why we have the flipped image in the end. Okay, so what do we have here? We have x val is equal to the floor of int points of I1 plus ranges of 1 times 0.5. The ranges of 1 is going to be from like -2 to +2 or something. And then we're going to do ranges over resolution of 1. And then we're going to say the y value is going to be equal to the floor of the int of points of I2. Okay, so what are we doing here? We're saying the x val is going to be... So we are saying the x value... Oh, I got to think about this. I really do. Okay, so here we're going to do the x val is less than resolution 1. Okay, so in all of these cases, we're saying the x val is the first value and the y val is the second value. So this says to me that our big problem is that our chaos game function is actually outputting points that are in the wrong direction. So let's go into view source and let's go into fractal flame.jl. We have the chaos game here, which is going to be -1, -1, 1.0. Right, so this is going to be 1.0 in y. But this should be read as, wait, no, this should be flipped. So it doesn't really matter if it's x or y in the end, right? All that matters is how we read it as x and y. So here we're going to say, yeah, this should totally be fine. I don't see a problem with this. So, okay, let's go back into our image tools over here. So we're going to say right image is going to be equal to points. Ranges, resolution, file name, point offset is equal to 10. All this is fine. We're going to say pixels is going to be 0 of tuple resolution. Does that mean we just need to flip this? No, that doesn't make any sense. The first pixel should be x value. The second pixel should be y value. Maybe it's in the save function down here. Yeah, I feel like it must be in the save function. So here, just to make sure that we're doing this right, let's just go ahead and transpose this. And let's just try this. Control D. And let's do right image. And now let's take a look at that image. Okay, so now it's flipped upside down. Which I suppose is also kind of fine. Because... Yeah, okay, that's also kind of fine because it counts from the top down. Okay. So yeah, so there's two things here. One, y counts. So here, a lower y value is up top and a higher y value is at bottom. And then also, yeah, we need the transpose here. So I'm not going to worry too much about that. I think it should be fine. We might just have rotated images every now and again. But I think this all should be okay. And I think this is outputting kind of what you'd expect. So fine, I'm relatively happy with that. I'm going to go ahead and commit this as well. So let's do git add source image tools, git commit -m, adding the ability, ability to, adding the ability to write, we'll say fractals to file. Okay. So the next thing I want to do, just so that we are on the same page here, is I'm going to do points is going to be equal to this, and I'm going to increase the number of points to like 100,000 or something. And now let's output that just to make sure this all does what we expect it to do. So now we're going to do this guy, and we're going to say 1920 by 1080, and let's just see what it looks like. That is outputting a lot of numbers, which it shouldn't do. That's okay. Check.png. Okay, so this is our 1920 by 1080 image. Note that it is actually, I think, 1920 in the Y direction and 1080 in the X direction. So probably shouldn't have committed that. Let's go ahead and open this up in GIMP so we can get a better look at that. So let's do GIMP check.png. And I think it's dang, it needs to be transposed. Okay, so let's do source image tools. Okay. Now, how do I make this so it actually outputs the right range? Simply put, what I might do, because everyone's going to want to input, 1920 by 1080. That's just what they're going to want to input. So what I might do is I might actually just do a little sneaky res is going to be equal to res transpose. And here we're going to say flipping y, or flipping, transposing, transposing resolution, because Julia expects y-axis first. Okay, and then in here, all we're gonna do is treat this like we want to treat it in Julia. So this will be y, this will be x, and this will be y, and this will be x, Oh, hmm. And this will be y and x. Those are both fine. And then we'll do y and x in here. Y, and then x in here, and comment this out. Write this, and now we're going to do ff right. And if we do check.png, this should be the appropriate... No, it's still... missed the start of stream. That's okay, Alexor. How are you? I hope you're having a great day. Okay. So the resolution is going to be equal to the resolution transpose. Should be fine. The y value is now the first value. The x value is now the second value. That seems fine. The y value is less than resolution of 1. The x value is less than resolution of 2. That should still be fine. I'm going to say that is because we need to do this transpose when we set the pixels in here. So let's do D2D, paste in here, and then initialize the pixels array here. So now let's try that again. And now let's try to take a look at this. What? What is going wrong? Fred Chemist, how are you? I hope you're having a great day. Yeah, let me go and catch up on chat. Mrs. Starter Stream. However, thank you so much for following. Sisui Kim, thank you so much for following. Really appreciate it. How have you been, Fred Chemist? It's been a while since I've seen one of your streams. I'm so sorry. I've been swamped with work. How have you been? I hope you're having a great day. For anyone who might have been in the stream and you don't know Fred Chemist, we've rated them on numerous occasions, but it's been a while. I feel like it's been a long time. She does a whole bunch of really cool chemistry stuff. Quite frankly, in my opinion, one of the, if not the best chemist on Twitch. I can't think of too many others on Twitch though, so I don't really know how big of a chemistry category we have on Twitch right now, but I will say, of the chemistry people I watch on Twitch, she's genuinely one of my favorite people to watch, so definitely go check her out. Let's see, computational chemistry. What do we have here? I'm catching up on chat. Please tell me this is about AI creating particles. It is not about AI creating particles. I'm so sorry to disappoint. She ran out of Wi-Fi juice, so she basically tossed us in here while she had to go dodge security. Oh no, I'm so sorry. I see some binary trees. Yeah, we got some binary trees here. 3D Prima, thank you so much for following. Really appreciate it. There's Professor Melko doing chemistry too. Oh, that's true. That's true. Yeah, I completely forgot. Okay. So what are we doing right now? Because we do have a whole bunch of new people here. We are creating fractal flames. Here are pictures of fractal flames. That's kind of what we're doing. And we are just getting started on this. We have not done this before. Well, we have done this before, but kind of crappily. So we're trying to create an actual package that creates these images. The heart of the fractal flame algorithm is something known as an iterative function system. So let me catch up on chat, and then we'll go from there. She's an organic chemist. Yeah, she was harassing the cleaning Roomba. Oh, I'm sorry. Did she steal the power cord or something? Okay. So what is an iterative function system? I'm going to show you an iterative function system by first talking about the most famous fractal, one of the most famous fractals in existence, known as the Serpenti Triangle. So we're going to start with points A, B, and C, and we're going to create three functions, all of which will return the midpoint between the point that you read in and A, B, or C. So we're going to then create three new children, and these three new children, D, E, and F, will then create three new kids. So those new kids create new kids, and those new kids will then move according to the functions we defined before. So for example, all three of them will send one kid halfway towards A, B, and C, and that creates a triangle of triangles. Now, if all of these children then create more children, following the same rules as above, where they create three kids, one kid goes halfway towards A, another kid moves halfway towards B, another kid moves halfway towards C, we then create a set of triangles within those, and triangles within those, and those, and those, and eventually you create the Sierpinski triangle visualization, which I'll pause here. And so that's kind of the idea behind the iterative function system. We have a huge, we have this idea of a Sierpinski triangle, which is an attractor. It attracts all of these points that are in some ways randomly moving about towards this shape. And yeah, that's kind of the visualization we're making here. We made this visualization a long time ago. You can find it on both the YouTube channel and also on the iterative function system chapter on the algorithm archive. So that's kind of, yeah, that's kind of where we're at. So let's go here. If I had to code that, it would be expensive. Oh, actually, if you were interested in how expensive that computation was, go to the YouTube channel, because there's a video on there called creating fractals with trees, where we actually talk about how we did that by actually counting up in a base 3 trit system. that if we used the appropriate counting system, we actually didn't have to store any of the tree in memory. We could just like count upwards, 1, 2, 3, 4, and this would actually create a breadth first search along the tree in order to create all of these points. It was actually really cool. Big fan of that. So definitely check it out if you can. JJ Smashing Pumpkins, Lyric Balloon 80, Master 8, thank you guys so much for following. Really appreciate it. I hope you guys are all having a wonderful day. Let me go ahead and catch up on chat here. It's a wireless model, but she kept standing in front of it and lying down in front of it to test the avoidance. Oh, interesting. It works pretty well on humans, not so much on Twitch chat. Okay, so now I need a translator. Hiding it in the over, I assume. I find the lack of MATLAB coding on this channel to be something. I'm sorry. Oh, soothing. That's fine. I don't like MATLAB. How are you, Legal Logan? Let's see. I guess it's a pretty accurate assessment of Twitch. So cool. If I had to code that, it would be expensive as... Okay, so I think I'm caught up on chat now. So where are we today? That's a very good question. Thank you so much for asking. We just got started, and right now I'm just trying to figure out why when I output this to file, it is transposed. That's where we're at. Sorry to disappoint and make you think that we are further advanced than we are. I'm just crap at coding, so it's going to take some time. So welcome to the crappy coding adventures of Simuleos. I think I could use that on 3D meshes. Yeah, so there's a lot of things. Right, so the whole point of this channel, in case you guys are new here, you don't know what we're kind of doing here, between the YouTube channel and the algorithm archive and stuff like that, the whole point is to better understand algorithms. So I don't tend to do things that are super computationally costly or things that abstract away the heart of the algorithm, right? Because the truth is I want to understand the algorithm, not so much, you know, like 3D meshes and stuff like that. So I tend not to do so much with that. But I've been thinking about moving into doing some of that stuff as well. What language are you coding in? It's Julia, VI Hype. We are definitely using VI. So let's do here, let's just do Simul VI. We have an emote for it. I've been meaning to port some of my Python code in Julia for a long time, but I'm too lazy. Dude, if you don't want to do the port, you don't have to do the port. We are expecting 1920 by 1080, 1920 in the X dimension and 1080 in the Y dimension, but we are getting 1080 by 1920. Okay, so when we're reading this in, here's our right image function. We're reading in 1920 by 1080. Let me not transpose that and see what we get. So we're going to write that. Now we're going to run that, and now we're going to run getCheck.png. Okay, it's still flipped, which says to me maybe I need to turn Julia off and on again. Maybe, I don't know. Maybe it's a revise issue. Just to check if it's a revise issue, let's go ahead and print something over here. Print line, whatever, yo, doesn't really matter. Try it again. Nope, that's not what I meant to do. Try this again. Okay, so it's not a revise issue. Okay, that's fine, not a big deal. So our pixels dimension here should be zeros. So we're just creating a bunch of just blank values for now. And it's a tuple of the resolution. So let's just output the resolution, maybe. Print line. Okay, try this. Resolution is 1920 by 1080. Let's do resolution transpose, because I'm losing my mind a bit here. Oh, it's still 1920 by 1080. That's because the transpose. Yeah, right. Okay, that just makes it a... That is something different than what I... Right, okay, fair enough. Good, okay, learned my lesson there. So DD here, DD there, and what I want to do is say resolution is going to be equal to resolution of 2, resolution of 1. And then down here, we're just going to say that should be fine. Let's go. So now we do this, and now we do check.png. Should be the appropriate resolution. Yep, it is stretched. Triangle should be flipped as well, but you know, I'm getting there. Okay. Reverse res instead of transpose. Oh, cool. Yeah, okay, thanks for that. Have you made sure it's not just a GIMP thing? Check Y and Z, zeros on the graph, where they show up on the top left or bottom left. Yeah, so it should be top left is 0 for Y and X. So we can do reverse. Reverse res, and now we're going to do zeros of, what am I doing with my life? 1 second. Tuple of tuple of resolution dot. That should do it. Okay, so this should work. we should still have the stretched triangle. Now we just have to flip that. So let's get that flip action going. Okay. So now we have all these points, and the first value of the points, I want to say this should be our x value, and that should be our y value. Oh, no. I understand now. Okay, but let's just do this, and then we're going to do that, and this should be the appropriate triangle. Flipped upside down, but kind of close. Okay. So that is because when you initially we created a set of points, and I assumed those points would be input x, y, but Julia assumed they'd be input y, x. So that means we do have to flip them. The thing is just, okay, so what I was hoping to get out of this was the following image. So let's just run this in GNU plot. And now let's just do plot points.dat. So I wanted to get this image. That's what I was looking for. But it seems to me that, let's see. It seems to me like we're not going to quite get that image. Let's see. I have to draw every time x, y, and z are changed. Let's see. I think 0, 0 is the bottom left for PNG. 0, 0 is the bottom left for PNG, but it's the top right for our coordinate system. So that's the main issue here. Zebby Oz, thank you so much for following. Really appreciate it. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. I am going to be streaming, looks like maybe another 2 hours and 30 minutes or so. And hopefully we'll get, you know, a bit of this fractal stuff being done. Hi, what awesomeness are you doing today, doing here? Yeah, so if you see this visualization up here in the corner of a Serpenti Triangle being generated, essentially right now we're just trying to regenerate this visualization in kind of a different format. So we're just trying to recreate the Sierpinski Triangle before hopping on and doing more complicated, you know, fractally patterns. So that's where we're at. Okay, so let's see. Right now our image is being plotted kind of funny. And I think that's because if I'm going to reverse the resolution here, I should also reverse the ranges. Not that that really matters in this case, because the ranges are also are the same. It's symmetric, or like it's a box actually. But I wanted to make sure that the wait, how are we off the map then? So we're off the map because we have the resolution. Okay, I see what's happening here. We're gonna have to mess around a bit. So we're gonna have to turn this into y value and x value as it's supposed to be. And then we say points of I1 is gonna be plus ranges of 1. The ranges of 1 are for the y value, but this should be 2 and this should be 1. Yeah, this is kind of messy, but if this works, then I'll comment it in and we'll figure this out. So let's do check.png. Okay, fine, fair enough. Now we just have to flip the y-axis. And then after we flip the y-axis, we should be good to go. Deck running, thank you so much for following, really appreciate it. Okay, so now we have to flip the y-axis, and how are we going to do that? It should be points of I, so let's do 1 minus that. Oh no, it's not gonna be 1 minus that. It's gonna be, I want to say ranges of 1 minus that, I think is what I want. So minus, or maybe I just want, wait a minute. I gotta think about this one really quick. Multiply y by -1. If we multiply y by -1, then we have negative y values, which isn't gonna help anyone. What we're actually trying to do is we're trying to make it so, let's see, so plus ranges, so we do plus ranges of 1 times 0.5. I think I just want to flip these guys around. So it's going to be ranges of 1 times 0.5 minus this guy here, points of I2. Okay, and I'm definitely going to need to comment this, but, you know, we'll figure that out in just a second. So did this work? Gimpcheck.png, that did work. Perfect. Okay, so let's comment this in. And let's think about what we want to do with this. Y max minus y in the next line. Right. Yeah, we could do that. I think this is okay. Cool. Okay, so let's go ahead and put some comments in here because I'm not going to remember this. So transposing, or rather reversing, resolution and ranges. Resolution and ranges. Because Julia expects y-axis first. And in here for the y value, let's see, for y coordinate, we are, okay, I gotta think about this. So here we also stated that our points of I2, okay, so the points are in, so here we have a couple things. So notes, points are in X, Y, while visualization is in YX. Okay, should be fine. I'm gonna have like something in here. Oop, screwed up there. Try that again. Put this here. And then we have one more note that we have to do. What is it? That's a button. Let's see. Okay, and then D $. Okay, so points are in XY while visualization is YX. That's one thing I have to point out. And the other, the Y value needs to be flipped because drawing should be from lower left. I think if I do LL, I think at least I will remember what that means. Like if I just say Y value needs to be flipped, I'll know what that means. I think you're right though. Okay, fine. I hear what you guys are saying. Let's, fine, whatever. Lower. All right, let's do it that way. And I'll just put a little dash up here. Oh. There and there. And I guess I want an extra space there and there and there. Okay. Quadrant 1. Okay, this is good enough for me. Let me add a, this. Okay. So now we are binning the pixels, we're writing the image, everything seems kind of fine. Let me make it so this is now 1000 by 1000 image instead of 1920 by 1080 because it is actually a square grid. I was just using 1920 by 1080 to check everything else. So now let's do get check.png, and this should be, again, kind of a skewed triangle, but it is a triangle nonetheless, and I think I'm happy enough with that. Let me increase the number of points just a little bit here by a factor of 10. And then we'll plot that as well. And now we should be able to do this. And now if we do that, we should have an even stronger, yeah, so we have an even stronger triangle. We can zoom in. You do see like, you know, pixel artifacts and stuff like that as you go further in. But again, that's just because we're binning the data. So you would expect to see something like that. Okay, I am now going to commit this again. Because you know me, I love committing things. So let's do git add source, image tools, git commit -m, adding version of right image. Let's see, ... that outputs as user expects or something. Okay, so we've got a bunch of different directions we can go in from here. I think what I'm gonna do is I'm actually going to add in the concept of a pixel. It should be, height should be √3/2 times width. Correct, but also, okay, let's just do it. Let's go into the source, fractal flame. Sorry about that. And now we're gonna say the height here is gonna be square root of 3/2. Write that. And the width here is going to be, maybe it's just square root of 3 then. Okay, let's go here and let's just do the last. In fact, I think we can just do points here. And now if we plot that and we take a look at it. That didn't work. I think we do need an over 2. I think I didn't know what width meant. So let's try it again. Points. Right image. Check.png. I guess that's right. Looks kind of right. I don't really know what a 60-degree angle looks like, so happy enough with that. I'm not too worried about it. Okay, so I think that's the next thing we're gonna do. We're gonna add color here. Cool. Cool. So let's do it. The VI source image tools. Okay, so to do this, I think what I want to do is I want to actually implement the concept of color and also implement the concept of pixels. These are two different things that I don't have already, but also color is just going to be RGB. So it shouldn't be too bad. So we should be able to go in here and just do struct pixel. 1 second, and here it's going to be, I want to say, I don't really know how we want to do this. Each pixel will have an XY location probably, and a color is kind of what I'm thinking. A color associated with it. I suppose in some sense we don't really need an XY index. It could just be a color. In which case, why don't we just turn it into a color? Oh, that's because the points have to come in with a color. Okay, that's what we need to do. So here we're going to write and quit. Okay, so now we're going to have every point have a color associated with it. And then we're going to, yeah, that's what we want. VI source. We have fractal flame, but what else do I have here? I've got flames. I'm going to put it in the fractal flame guy for now. So let's go in here and we're going to do struct. And I'm going to call it point. End here. Not the best name. But the point is going to have an XY location, float 64. 64, a Y location, which is again going to be float 64. And then we're going to have a color associated with it, which should be RGB. Here it's going to be, I guess I'm going to do C for RGB. And I suppose it can also have an alpha value. So I might do a union here of RGB and RGBA. That way it can be either RGB or RGBA. And that could be useful for cases where, I don't know, for some reason you can't use an RGB value as an RGBA. And in here, I think what I'm also going to do is I'm going to go into VI source, F flameify, and I'm just going to say using images. This way we always have RGB available, and go into VI source, image tools, and remove images from here. Okay, so now points have the concept of an RGB value. So what we're going to want to do is we're going to have a set of points, all of which have an XY location and an RGB value associated with them. So I think we just have to go through all of the points. Hey, Flood from No here. How are you? It's been ages. I hope you're having a great day. Oh man. It's been ages. Like every time I see your name in chat, like, I know it's Fled from Nowhere, but because you made that one joke, that one time that said it's Fled from Now Here, you know what I mean? Hey, you see MATLAB at University? Cool, okay, you, I know it's nowhere, but you made a joke once that said it was Now Here, and then from then on, I always say Now Here, and I know it's nowhere, but I don't know why, my brain just is like, Now Here. Okay, so I think what I want to do here is size of points, I think is correct. And here we're going to have points be, so let's go here using, do we have to do using, or maybe we can just do include, and include, I guess we're going to do fractal flame. Or we can do this the dumb way, which if you know me, I always like doing things the dumb way. This will be fine. It is what it is. I'm not going to worry about it too much. Okay. Image tools here, and we're going to say points, which is going to be a vector of point. I guess I'm going to say array. Well, we'll say vector of points. Point. Okay, ranges, file name, and let's move this down to the next line. I did that wrong. Try that one again. Okay. Now I did it right. Okay. If it ain't broke, let's see. Mathematica is nice. The kernel with command line interface is free to download. Not as nice as notebooks, but has a nice ASCII graphics formulas. Yeah, I mean, I don't actually have a problem with Mathematica. Like, fine, I've never had to use Mathematica, so I don't really have a problem with it, right? But I'm sure, like, I'm sure that, you know, a lot of people have problems with it. Like, I think most people have problems, not necessarily with Mathematica, but with the functional nature of Mathematica. Like, there's some issues with it. That people have. Okay, so now we have points of I2, so this should just be points dot y, I believe. Yeah, points dot y. ry, ry, there we go, and this should be points dot x. Oh, points of I dot x plus, and this should be points of I dot y. Okay, so now we have the x and y value here, and we know that the pixels should be of type RGB. So here, I guess what I'm going to do is specify them all as type RGB. So it's going to be, can you do zeros of RGB? Does that work? It does. Okay, so let's do zeros of RGB, but I think you can't do it of RGBA. And we're going to do pixels. It's going to be dot plus equal to, and I'm just going to add in the pixel color for now. So we're going to do points of I dot C. But let me think about this because we're going to have to blend it with the other colors. So how are we going to blend it? I think what I'm going to say is I'm going to create a new function to mix the colors. Now let me think. How do we want to blend it? We want to make sure. I suppose we can have a number of pixels in. How did I do this before in the old code? I think I had a struct pixel that had the value, which is a float 64 and a color. Okay, and that's how I did the blending, I'm pretty sure. So I think that might be what I want to do as well. I want to have a pixel with some sort of color associated with it, with some sort of value associated with it. And then every time you add in a new color, you blend it because you know how many points are already on that pixel or how many points have been binned into that pixel already. So let's go into VI, source, oh, I'm in the wrong directory. So let's see, I'm going to go up here and we're just going to go ahead and create that set of pixels. So let's do struct. And I suppose it does have to be mutable. Pixels. Okay, and here, and in here we're going to say value, and then we're also going to do float 64 should be fine, and then color of our union of RGB and RGBA. Okay, seems fine to me. Okay, so we've got a bunch of refactoring to do here, but hopefully at the end here we'll have like a blue Sierpinski triangle instead of a white Sierpinski triangle, and then we can go from there. Tinkering with it, that's my saying. Let me get some water again. And then we'll just kind of keep going. Okay. So we have this concept of a pixel. Let's modify the right image function. Well, okay. Let me just go back a bit to Fractal Flame, and I want to also change this to does it need to be mutable? Maybe it doesn't need to be mutable. Maybe it's okay if it's not mutable. Okay. Image tools, pixel. Okay, and I think what I want to do is I want to create a quick constructor for this, which is going to be pixel of 0, we'll say, is going to be equal to pixel of, and I guess I want to do 0, I'll do 0.0, and then RGB of 0. Okay, so now we can do this, and we can just say all of them are going to be. Can we do that? Zeros of. Can I? Wait, what happens if I do? I don't think that's gonna work. But can we do? How do I create this array? So we know the dimensions of the array. So can we do array of type pixel? And then we do, 1 second, pixel of 0. Are we allowed to do this? I think this might break. But that's okay. We'll try to figure that out. So we're going to do dot .c. It's going to be equal to dot plus, actually, it's going to be equal to, and we're just going to say mix color. And I'm going to create a function for this. It's going to be points.c with, I suppose it's going to be, what is it going to be? 1 second. Pixels of yval, xval, dot .c. Okay, and that should do it. So let's go ahead and create that mix color function. And here we're going to say mix color function mix color, and it's going to take in 2 things. One thing which is going to be a pixel. So it's going to be pixel, okay, maybe. And it's going to take point, which is going to be point. All right, and here, yeah, maybe we should think about how we're going to do like points and stuff like that, but let's just keep going. So here we're just going to return, actually, I think I'm just going to mutate the pixel here, and then we're just going to mix colors on the pixel. I don't really like doing mutation like this, but I think this is an easy way to do it for now. So what are we going to do? We're going to say pix dot val is going to be plus equals to 1. That's definitely going to happen. And then the color should be a combination of the other colors. So how are we going to combine the colors? Well, it should be weighted based on the value of pixels that are already in that bin, right? So if we have 5 pixels, then it should be 5 parts. So if we have 5 pixels and we're adding 1 more pixel, it should be 5 parts whatever color it was before, and one part the new color, right? So I guess what we're going to do is we're going to find a ratio here. So let's just create the ratio. The ratio is going to be equal to pix.value divided by, so it should be like 4/5, so it should be pix.value plus 1. Okay, so that's the ratio. It should be like 1/5 or 4/5. Wait a minute. Let's do, okay, well, let's just do it. Screw it, I'm thinking too much about this. Pix.c is going to be equal to pix.c times ratio plus, okay, let's do 1 over that. Oh, why am I doing this in a dumb way? I know exactly, we want to, it should be pix.c times pix.value. Okay, 1 second, I'm learning. Pix.c times pix.value plus p.c divided by pix.val plus 1, and that should be it. There you go. That's all we need to do. So we mix color, we have the new mixed color. Does the rest of this just work? Let's see, so we have, assuming this pixels of 0 thing works, which I'm not entirely convinced it will. So that's a sticky point right there. So we'll take a look at that later. Let's go into Fractal Flame and modify this so it now returns a bunch of points. And let's do it that way. So here we're gonna have points of 0. I'm initializing the points beforehand. So let's see, triangle points is going to be a set of, I want to say this should be a set of points. Okay, so we're going to modify this a bit. Okay, because we're going to be testing out some of the functionality that we need for the rest of this code. So triangle points is now going to be a set of 3 points. So let's go into VI source and then flames, and let's modify this. So we're going to actually create a new function, yank for yank, paste it up here, and this is going to take in points instead of taking in like any instead of taking in any, it takes in specifically the struct point. It might be a bit more computationally efficient just to divide at the end by val. Don't know what you mean. Let me see. Let's see. Image tools. Divide at the end by val. So you're saying... Yeah, I don't know what you mean. I'm so sorry about that. Pix.c is the pixel color is going to be equal to... I can't see how to make that better. I'm sorry about that. I'm thinking about it right now, but I can't see it. So I'm going to leave it as it is for now, and we'll just keep going. Okay, so now we're going to do image tools. See, things are getting kind of sticky now. So let me go ahead, CD into source, L is here, and let me just go ahead and create a new file that we're going to do, we're just going to put all of our structs into one file, because at this point I'm messing up with everything. So we're just going to put all of our structs into one file. So we're going to cat image tools, and then we're going to cp fractal flame into flame structs or something .jl. Okay, let's go into vi flame structs. Grab this guy in here. and also that guy as well. Okay, go down here, paste that, DG, right quit. Okay, so cd back directory, vi source, ff, flameify, and in here we're just going to include flame structs. One second, structs, .jl. Okay, we do flames, fractal flame, and image tool. All that should be fine. Add that there. Go into vi source, image tools, and delete this in here. And we're going to go into vi source, fractal flame, and delete this guy in here. Okay. So the first thing we're going to do is modify the flames function so that it can read in points. .jl. Okay. So this is now going to read in a point, which is going to be of type point. And it's going to be shape vertices, which are going to be of type vector of point. So specifically, if it's of type vector of point, it will do this. I was thinking just keep adding all the colors together and then divide by the number of colors at the end. But that would require a whole loop over all the pixels for something that occurs rarely. So dividing, multiplying each. Oh, I see what you're saying. Yeah, actually, maybe that does make a bit more sense. Yeah, since we are keeping the value, yeah, we can just do that. And that could be like our normalized function at the end or something like that. VI image tools. Okay. Keep it the way you have it. I think for now I will keep it the way I have it, but that's a good point. Okay, the flames.jl. Okay, so now the shape vertex is going to be shape vertices of rand 1 to length. Okay, so that's going to be our shape vertex. So now what I want to do is, I think I'm going to create a new point. So we're going to say, I guess I don't know what to call it. I'm just going to call it red point. Is going to be equal to point of, I think it's 0, 0, 0 should work. And then we're going to say, actually, I can just do it this way. Return point here. And then let's see. We have an X and a Y value. And so the new X and Y value is going to be, okay, so it should be, 0.5 times point plus shape vertex dot X. Sure, let's just do it. 0.5. Yeah, let's just do it. Screw it. It's not. Point dot X here, shape vertex dot X. Okay. And now we need a comma there. And so now for the Y value, it should be the same thing as above, but dot Y. Okay. Dot Y, dot Y. Okay. And then finally, we're going to say flame color, which we have to define. And that should be fine. So now let's go ahead and define a flame color. And for now, just because I want to keep it simple, let's just have the flame color be equal to just blue, RGB, and it's going to be 0, 0, 1. Okay? And so this should make it so anytime we go through the Serpenti function, we create a bunch of blue points. See how it goes. What do you use for math problems? A local Mathematica installation is faster than Wolfram Alpha. I like interactive style. Quick test. Hello everyone, what are we writing? So I'll talk about that in just a second. Let me go and take a look at this image. Let's see what we have. Yeah, so okay, so for me, I don't really have to, I have rarely come across a problem that I actually need Mathematica for, or Wolfram Alpha. So for me, I don't really need this, but I understand that for a lot of people they might. Ibronsky, thank you so much for following, really appreciate it. So yeah, it's just for me in particular, I haven't needed Mathematica. I also find notebooks really cumbersome, and Mathematica notebooks are probably worse than Jupyter notebooks. Like Jupyter notebooks are really cumbersome. Mathematica notebooks are like doubly cumbersome. I'd rather just do all the symbolic manipulation via like symbolic utils in Julia or something like that, or even build my own compiler for that. Usually I'm looking at different problems that are like, you know, require some sort of performance discussions and stuff like this. So Mathematica is not usually the tool that comes to mind when I think about this type of stuff. Okay, so the question of what am I writing, board spaghetti? That's a very good question. Thanks for asking. So if you look at this visualization here, you'll see that we start with 3 points, A, B, and C, and then we have 3 other points, D, E, and F. Essentially, all 3 of these points, D, E, and F, will generate 3 kids, one of which will move halfway towards A, another which will move halfway towards B, and another which will move halfway towards C. A, B, and C. Okay, so now if those 3 children then generate 3 more kids, and they all send their points around, and those kids generate more kids, and those kids generate more kids, and more kids, and more kids, and I think one more batch of kids, you eventually generate what is essentially the Sierpinski triangle. This is known as an iterated function system, and it's the heart of a method known as the fractal flame method, which can generate a whole bunch of really cool, really cool visualizations that we'll get into soon. Right now we're at the very start of this particular code base, so we're literally just regenerating the Sierpinski triangle, but at some point it should be way cooler. Oh, sorry about that, I hit the microphone. I hope that wasn't too distracting. But yeah, that's kind of what we're doing right now. Okay, so let's keep going. Do you know chemistry actually? Could this maybe be used to compute self-assembly, etc.? I don't know chemistry as much as I should. So here's the thing. Fract Chemist, for some reason, thinks that I do computational chemistry, and though I have done a bit of computational chemistry, I've only done it in the quantum sense. Like, for example, density functional theory and stuff like that. I have not done it really with like balancing equations and stuff like that. So I'm not very good at chemistry, and I can definitely not say that I know chemistry enough to be able to answer your question. Board spaghetti, I got my PhD last, I guess, December, in, I guess you could say, computational physics. And right now I work at MIT doing, I guess you could say, climate research in a way. But mainly I do high performance computing, computational science, and stuff like that. So that's my background. Let me get some water. Okay, so let's go ahead and keep going. So we have the flames made. So now let's go into the fractal flames. So let's go into VI source fractalflame.jl. And now we have to modify this so it also takes in a bunch of points, which means that we probably want to create a constructor. So let's go ahead and create a constructor for points, VI source, and let's do, what was it called? Flame structs. And let's go ahead and create some constructors here. So we're going to create a point of 0 is going to be equal to point of 0, 0, 0. Should work, I think. I'm going to do RGB of 0 because I just realized. Okay. Like quantum HPC, even better. That's the thing, right? Like I don't know so much about chemistry. I probably should, but I really don't. And it's been a long time since I did any DFT calculations. So what do I know? I really don't know much about the area. Honestly, ever since I've gone to MIT, like my knowledge has just dropped tremendously in these areas. Like I used to be able to like keep up with pretty much any conversation in any computational science domain. Now, like I'm just struggling to like even do my own stuff. Like I don't know what's happened, but since I've come here, because I guess maybe because I haven't been focusing so much on reading the literature and keeping myself up to date there, I've actually just been kind of like, the truth is I'm not really a science guy. I don't really like, you know, doing physics or chemistry or anything like that. Have you done computational biology? Just a little bit, not enough, like edit distances and stuff like that. I did enough biology to know that I didn't want to do sequencing and stuff like that. It's just frustrating. Okay, so we have point of 0 is equal to that. I think that's actually what we want. So let's just right quit, go into fractal flame. And I think we're just gonna say the following. I know this is dumb. We're gonna do it Pythonic. So we're going to say point of 0 for I is equal to 1 to n. Something like that should do. $. Okay. So in here we're going to create, that's what I needed. Right quit. Here I'm also going to create a new flame struct, yank paste, which is going to, I think that's still fine. So here we're going to read in an x and a y, and this is going to read back xy. And that should still be fine, I think. Why not? Who cares? There and there. Sure. Why not? Seems fine to me. Okay. Yeah, it sucks knowing that at grad school you will be strongest in all areas of physics. Defense work R&D make you dumb? I'm not doing any R&D research or like, well, okay, I guess it is R&D research. I guess you're right. It is research and development. It's mainly just that in the past year, I haven't really done any actual research. It's been entirely software engineering for the whole year. I've done nothing but software engineering. And the truth is, yeah, like software engineering is fine. It's fun. But like also, you know, you can feel your skills kind of atrophy a bit when you don't use them, you know? And that's kind of how I feel like things are going with my current job. So, you know, okay, anyway, we're going to do yank paste and we're just going to say the $, and it's just going to be point of, and we're just going to read in -1, 1, point of 1, -1, and then point of 0, and then square root, just this guy. Screw it, I don't feel like typing. You guys just deal with it. Okay. That should work. I don't know, just making stuff up as I go along. So points of 1, colon. So this is where things get a little bit interesting. We need to initialize the x and y location for this. So we're just going to say points 1.x is going to equal to that, and points 1.y is going to be equal to that. In fact, maybe I can do this in a different way. Let's go ahead and dd there, and let's actually do it this way. So we're going to say points of 1.x. Let me just see what happens if I do this. If I do points of 1.x and then points of 1.y, and then I set that dot equal to that, and that should work, I suppose. And I think we can just pull the same trick down here. So if we do points of I dot x, oops, sorry about that. And then we do points of I dot y that equals that. I think that'll do it. And then Sierpinski, oh no, Sierpinski returns a point, I believe. So I think I can just do points of I is equal to that. And I think that'll do it. Okay. This is going to break. This is going to, I don't want to run it because I know it's going to break. Yo Gam, thank you so much for following. Really appreciate it. Okay, so let's write this. Okay, let's just break it now. I know it's going to break. So just, there you go. Look at all these method errors. Wonderful. Okay, no methodmetric flamify.point. Let's control D, open up Julia again, and let's just, using revise, and then try it again. Using flamify. There we go. Give it a second to precompile. It's going to break, probably during precompile, but that's okay. As a computational blank, have you looked at Wolfram's work on hypergraphs? I have not, because I don't know, I just haven't. 0 is not a valid function argument name around. Okay, fair enough. That is okay. I was hoping to make it. So here we have flame struct. So that initializer doesn't work, but don't they have type 0? I thought they had type 0. I guess not. Okay, then let's just do it this way. You know, screw it. It's not worth it. We're going to do point of x is going to be just... let's just have point of xy, and then pixel of x is just going to be this. X. Okay, so do we actually use point of 0? We do. So let's just do point of 0, 0. Okay, now let's just do, what am I doing? One second. I think I was just using the package. Let's try that again, see what happens. Why is breaking? Could you explain? It is breaking because I basically refactored the entire code base. That's why it's breaking. So right now it's breaking because there's a type error in pixel type definition, expected type, got value type of image core float 64. So let's go ahead and hit that. So it's in flame structs 9 is where it's breaking right now. And it is breaking, it's beautiful struct pixel. It is actually breaking in, oh, it's breaking in the compilation. Failed to precompile. Type error in pixel. Union, in type definition, expected type got value of type of image core float 64. Oh, that's because I didn't capitalize the F. Okay, fair enough. try that one again. So essentially, the issue here is just typos. That's why it's breaking. Exception space for dot, not allowed point x dot, flames 4. Okay, that's great. We're getting there. So let's go into source flames. .jl, and where's the issue here? It's just dot. That probably should not have been a dot. That probably should have been a plus. And that also probably should have been a plus. Yep, that's fair enough. Try it again. So again, this is all just typos because I refactored the whole code base. We kind of expect to get typos of some sort. And by code base, literally just like 100 lines of code. Not even 100. I have no idea how many lines of code we have here. Like I just started it. Okay, so that seems to run. Let's just run points is equal to that. Error, wonderful. So let's go ahead and fix that. Okay, so this one is breaking on line, Chaos Game 5, Fractal Flame 5. So points of X, points.Y, I guess expected that to break. You know, I was hoping to do something tricky, but that didn't seem to work. But maybe I can do this. No way that's gonna work, right? Are you working? No, it didn't work. No method matching length of flamify.point. This is in line, let's see, Sierpinski, flames 11. Okay, that's fine. Oop, sorry. So let's go flames, line 11. Why are we even on line 11? We shouldn't be. So we're going to specify this only to act on float 64, a vector. Float 64. And also for the shape vertices to be a vector. I suppose they're not vectors. We'll say array of float 64. And this will also be an array of float 64. All right, run that. Try that again. No method matching Serpenti, array of 0.1. Array of flamify.1. Okay. I guess what I need is specifically decasses on f flamify dot point. That seems a bit weird to me that I have to do that, but does that work? No method matching Serpenti of array Sierpinski. Am I misspelling something? Sierpinski of array float 64.1 and array float 64. It looks like I have that function. Serpenti flamify.point. Oh, it's an array. I see. I see. Okay. So let's see, what do we have here? Fractal flame. This is being called on line 8. Okay. Points is Serpenti of points. That should be right. Try that. No method matching length of flamify.point. Great. We're back to that error. And this is going to be on line 8. No, it's going to be on line 8. What? I'm on line 8. There's no length in this line. It's because of the broadcasting here. Oh, okay. That's because it should just be points of I. Okay, cool. So now we have a bunch of points. Okay. They all seem to have the right color. That's good. So now we're going to try this guy. Right image, of course, breaks, but that is okay. We're getting there one step at a time. Let's go to VI source, image, tools, and we're just going to knock it out. So no method matching array of flamify pixel n. So what line is this on? This is on line 12. Okay, so it says pixels is array of pixel. Yeah, okay, I kind of figured that would not work. So I think what I actually want to do is, okay, so let me think. How would I initialize the array? Let's just initialize them all as undefined for now, and then we'll set them all to be. I don't like this so much, but it is what it is. So now we're going to say pixels is going to, pixels of this is going to be dot equals to pixel of 0. Should be fine. Try that. Okay, there's no method for length of something at pixels, probably another broadcasting issue. Okay, so this is going to be on line 13, which I think was the line I just wrote. That is the line I just wrote. So what's your issue? Pixels is an array of undefined tuple of resolution. So, right. I don't see what the issue is here. So let me get a little quick sip of water. Okay. So we have the ability to write the image on line 13. It says on line 10, image tools line 10. Okay, okay. In write image on line 10, it says we have an issue, and it also says we have an issue on line 13. Okay, so we have an issue on this line somehow, and this line somehow, and I'm not exactly sure how. So maybe let's just print line here. Pixels or something. See what we have. Yep. I guess it's kind of what I expected. Let's do size of pixels. All right, well, that's what you get. Try it again. 1,000 by 1,000. That is the exact size that you expect. Great. Okay, so it is 1,000 by 1,000. That's wonderful. We want it to be that size. Now, why am I unable to? Let's do tab, and we're gonna do pixels of 1. Access to undefined reference. Okay. That's interesting. Let me dd here, and let's just return pixels. All right. And we're just going to do pixels. It's going to be equal to that. Okay. So pixels of 1. Okay. Pixels of that. Pixels of that is going to be equal to pixel, I guess, flamify dot pixel of 0. Indexing assignment with a single value to too many locations is not supported. With a single value to many locations is not supported. Why would I need to broadcast that? That's not going to work. Type of pixels should be, yeah, it's okay. Pixels of 1. Okay, yeah, of course it doesn't have a type. So essentially we have a struct or an array that is of type pixels, right? Or type pixel array 2. I wanted to set all of those values to be pixel of 0, but I wasn't able to do that. So wasn't the constructor pixel 0, 0? No, that was the that was for point. So if we go into Fractal Flame, we go into source flame structs. We have point, and that's point xy, but pixel is just going to be x. It was meant just to have like a value, so it was just meant to be how many colors are already on that point. So this should be fine. I'm not exactly sure why I'm not able to broadcast that. So let me just try this again, and let's do a is going to be equal to array. Maybe I'm doing something really dumb here. Float 64, undef 10 10. That's what I'm doing. So that's what this value is doing. Let's explain. So, sorry, I'm in the wrong file. This right here is doing what you just said. You're iterating through all the values. So you're broadcasting along this, and then you're setting all the values to be pixel.0. But I'm not able to do that because for some reason I'm not able to set the values in the array to be that defined pixel value. Okay, undef of float 64 is apparently point maybe undef, and now let's do a of 1 is gonna be undefined, a of 1 dot or just equal to point flamify dot point of 0 0. That works. Okay, let's try this again, and let's try pixel. Okay, now we're gonna do this is gonna be pixel of 0. That works. Does this specifically need to be f flamify? I don't understand. Okay. Okay, so what is A? A is of type RGB. Okay, so let's say pixels is going to be equal to that. Okay, so let's do type of pixels. All right, and type of A. They look like the same point to me. So A of 1 equals that. Pixels of 1 is equal. Why is that working now? Pixels of colon dot equals. Why does that not work? Yeah, why does that not work? Time for some more list comprehension, you like? I can't do that in this case. Okay, I actually don't understand why broadcasting fails in this case. I really don't. Right, I know I don't have a length, but it's a struct, right? Like, it should always just return. I mean, I can define that length of point pixel equals. Let's do length of x of type pixel. I don't understand, Julia, but isn't each element of the pixels an array? It's 2D, right? No, in this case, each element of the pixels is not an array. Maybe you define the length? Yeah, I could define the length here, but that doesn't make sense to me. But let's just do it. Function base.length of, I guess, A, which is of type pixel, return 1, and pixel not, I guess it's going to have to be flamify.pixel. And now let's try that. No method matching iterate for that. Well, that's because you don't iterate over it. It only has one value. It's a single struct. What is your problem? Okay, A is going to be equal to that. A of 1 is going to be equal to that. A of colon is going to be dot equal to that. Okay, I'm not fully understanding what the issue is here, but I'm just going to do this the dumb way and just not worry about it and just say there's a way to do this with broadcasting, but I couldn't figure it out. And in here, I'm just going to comment out what didn't work. So pixels of colon is going to be dot equals to pixel of 0. And I'm just not going to worry about it. For I is equal to 1 to length of pixels. And the error with using pixel 0, it just didn't work with pixel 0. Like that, that's not a valid way to create an array. I guess I can do it this way. I can do pixels. Okay, this is a pain in the butt, but I can do what's the size that I'm looking for here? So if we have an x and a y, it should just be x times y. So can I do a multiplication of x and y? So let's do pixels is going to be equal to pixel of 0 for I, j maybe is equal to tuple of resolution dot dot dot. Maybe that'll work. I don't know if that's going to work, but we can try it. Sure, whatever. That didn't work because I'm apparently for ij is equal to it needs to be 1, 2. That's not going to work at all. Yeah, it's just not going to work. How do I multiply two values within a, like, what's this called? Like, if you have 1, 2, 3, 4, right? And I just want to do 1 times 2 times 3 times 4. It's like a multiplicative sum. So do I have to map the, so let's say A is going to be equal to 1, 1, 2, 3, 4. And then let's just do map. Can I just do multiplication over A? No, that didn't work. Or I could just say max element size. Like hcat of f of I for I is 1 to length. That's really annoying. Let me just do it this way. We're just going to say max size is going to be equal to resolution of 1 times resolution of 2. And then we're just going to do this for I is equal to 1 to max size. And screw it. I'm not going to worry about this. 1, 2, 3, 4 dot reduce. Screw it. I'm not worrying about this anymore. We're done. It's a pain. Should we reduce? Oh, okay, I see. 1, 2, 3, 4 dot reduce of AXI. Yeah, I mean, yeah, we could do that. Mulikan, who, thank you so much for following a few minutes ago. Sorry that I missed that. This is another language. I don't know, Julia. Okay, then I don't know. Sorry about that, Perkenji. Okay, whatever. This will work. I'm just not worried about it. Okay, so let's just try this again. Here, right image, no method mention colon. Okay, what line is this on? This is on line 16. We have gotten further. Kind of. Size of points. I think that's because points now is going to be, should be length of points. Try it again. Error to attempt 100,000 element at 5133. Okay, that's because we're, for some reason, indexing them with 2 dimensions somewhere. So let's do points here. Points of I, points of I, points of I. Eh? Let's do expression for in A, B, J. Right, so I was going to try this one, A, B, but the problem is because I have to do this stupid, I had to do that stupid like tuple thing. Because of that, I couldn't easily figure out what was X and Y in that case. DEFCON 201 live, thank you so much for following, really appreciate it. Okay, so what's the issue here then? It's going to be on line 25. Mixed color. Okay, so it's in mixed color. That's fair enough. Is on mixed color. Line 25. Oh wait. Oh, I see. It's pixels. It shouldn't be pixels of Y val X value anymore. It should be pixels. We have an X value and a Y value. Oh, I see. I see what happened here. Okay, so now we have, okay, so now we can do that though, because we don't have to do the tuple thing. So we're gonna want to do I from, oh gosh, resolution of 1, J equals 1 to resolution of 2. No method matching mixed color for RGB point. Okay, this is going to be on line 25. Okay, so no method matching mixed color for... oh, that's because it's just reading the pixel and the point, not the pixel and point color. Try it again. Okay, this seemed to do something almost... No method matching is less, and this is going to be on line number 10. Right image 29. Okay, and that's this last bit here, where we divided all the pixels. I think we don't need to do that. What we need to do though is we need to turn the set of pixels that we have into an RGB array. So I'm going to create a new function here, function to RGB, and this is going to take in a pixel. And yeah, and here it's just going to return pix.c, and that should be it. So now if we do to RGB dot pixels, I guess here or something. That should do it, I think. Let's see what happens. Ah, crap. Ah, crap. Ah, crap. Okay, let's quit there. Try this again. Okay, so we're going to create a new function to RGB of pixels. And there, and now we're going to return pix.c, and then down here we're going to do that again. So it'll be to RGB dot pixels, probably colon again. There, and then we need to do that. And I think that's what I need. So let's try that and go here. Okay, we're getting there one step at a time. That's okay. You know, it takes time. This type of stuff takes time. Failed to revise. Pixels not defined. Okay, well, let's just write that. Try this again. Control D, Julia, using revise. Using, come on. Okay, give it a second to precompile. Let me get some water. Okay, pixels not defined. What do you mean pixels not defined? This is on line 6. Oh, this, are you kidding me? Okay, try it again. That's how programming works. Okay, what I might do after this is done is I might take a second just to do an algorithm archive PR. So once we have this kind of working, wait, what am I doing? I need to do points. So once we have this kind of working, I might take a second to do an algorithm archive PR just because I'm feeling a bit burnt out a little bit. So let's see. Give this a second to do everything. I don't know if it's going to work this time. Ideally we have a blue Serpenti Triangle. So Mirage, check.png. We have, if you're looking, nothing. Completely blank. Okay, let's try opening it up in GIMP. Check.png. Just to make sure. Okay, that's fine as well. Cool. Okay. Right. So we have nothing. We do have a set of points. We don't know if it's outputting things correctly or not. So we have the max size, which we don't need anymore. Let's just output size, size of pixels and see what we have here. Right, that, go over here. Try it again. So why is it taking longer this time? Okay, 1000 by 1000, that is correct. We have the X value and the Y value. Let me just output pix.color anytime we're mixing. Print line pix.c. Try that. Seems fine. Although admittedly probably a bad idea to do this in the first place. Is it the 2 RGB that's failing? Huh. Control C, because that's taking too long. Just because we have too many points. Okay, so we are mixing colors, I think, appropriately, probably. I'm not really sure, but it seems like we are. So let's see. What is the issue now? We are going to do, we have pix.c. So if we do 2 RGB on pix of pixel, so how about we just say that image G is going to be equal to just 2 RGB of pixels here. How about print if val is greater than 1? Yeah, or we just don't need that. So now we're going to output the image here, the $ img, and now is here and just return image. Okay, so now we're going to go here, and img is going to be equal to that. Okay. It looks like it's fine. So I am show, I am view, img. Right, of course it doesn't. Attempt to access 1000 element array. Wait a minute. img is okay. That explains it. is going to be 2 RGB of pixels of I comma j. Oh, I hate doing this. For I is equal to 1 to resolution of 1, j is equal to 1 to resolution of 2. Something like that should do. Try that again. Give it a second. Okay, so now we have a 2D array. So now if we open this up in GIMP, we should get... Okay, not quite what I was looking for, but it's something. It is definitely something. Okay, so now the question is our triangle off, or is our image viewing of the triangle off? It's a good question. Don't know the answer to that. But we do know that each point now has a definite x and y value. So let's try to see what happens if we do this. Plus ranges of 1. Okay, so we're going to do image. What happens if we do view of image? Does that work? No, it doesn't. Okay, fine, whatever. So let's just do GIMP check.png. Okay. So are we using the wrong triangle points? Maybe. We have an x and a y value now. Yeah, it's an interesting drawing. Can you say EMG is equal to map to RGB? I probably could. I don't really know. I'm not very good. Maps are hard for me. Okay. So now we're going to say, why is our triangle all messy? I don't understand. Yeah, why? I don't... Okay. Did I get something? Maybe I did something dumb. Let's go in. Okay, 1 second. I deleted chat. Always takes me a second to get chat back up. Give me just a second. Okay, IRSSI. Join simu leios. Okay, good. Back. Sorry about that. Okay, so let's take a look at our source fractal flame. We gave it a point of -1, 1, a point of 1, -1, so that'd be -1 in x, 1 in y, -1 in x, 1 in y. Oh, maybe I just gave it the wrong points. -1 in x, 1 in y. 0 in x. So now we want +1 in x. So if we turn this to a -1, and then we go over here and we say points is equal to that, and then we do image is equal to that, and then we take a look at the last image. Sorry about that. Okay, so there's our upside down triangle. That's not bad. Okay, we're getting there. Now we just have to flip the y-axis again, which is great. And then after we flip the y-axis, I'm going to take a second to do an algorithm archive PR. Let's just go here, there, minus, here, write that, try that one more time, and then this should be, let's see, the appropriate Sierpinski triangle. There we go, perfect. Okay, one last thing I need to do, just because I want to do it, just to make sure it's working. Let's go over here and let's do the flames. Where's the flames? Here. And I'm actually going to make it so it returns a random in RGNB. Rand. Okay, so now over here we're going to do points is equal to that, image is equal to that, and now we're going to do the GIMP over here. That's maybe okay, and it should be okay. So now it's of a bunch of random values. I just had to make sure that the averaging was done correctly. So let's go ahead and write and quit. Go into image tools and let's not return the image anymore. So D2D, write and quit. Git status, git add, why is points.dat? I don't understand why points.dat was included. I have .dat in my, oh, is it, that's because it needs to be star.dat, because I'm a freaking moron. Okay, that's fine, whatever. Okay, write and quit. Get status. Get remove points dot dat. Get status. Force. Get status. Get add dot. Get status again. We do have PNGs and stuff, so let's do get reset. Get status. Get rm points dot point. What the heck? Oh no, it's deleted. So let's go into vi dot get ignore, and let's go down here and also ignore star.png, and also ignore star.jpg. Okay, get status again. Get add dot. Get status. Okay, is this what we want? All of them are JL files. We deleted the .dat file. We have project.toml. Git commit -m. Fixing. Let's see. What did I do here? Fixing Sierpinski. Visualization to take color, and yeah, I think just take color is fine. Okay. Git log. Okay, so now I'm actually going to rebase a bit. How do you learn to use Git? Are there any resources you used? Honestly, I learned to use Git by just using Git. I know that sounds really stupid, but I genuinely I used it a lot, and that's how I learned to use it. So I'm sorry. I do think that the how to contribute guide on the algorithm archive is actually pretty good. So if you go to GitHub and then you go to the, one second, and you go to wiki and how to contribute, this guide I think is actually really good as a prepper to explain like how you can use Git and version control. It explains branching and forks and all this kind of stuff. So I think it's actually really good. But obviously I think so, right? So I'm gonna actually squash these guys really quick. Git rebase -I head. Let's see, 1, 2, 3, 4. 4. Okay. And we want to do, I think we want to squash these guys. So let's do 4x there. And let's just squash that. Perfect. Write and quit. Okay. And I think we're just going to do that. Just adding a simple Serpenti visualization. Perfect. Write and quit. Okay. Git log. And this should just be one commit. Good. Let's just do Control D over here. Oop. Make sure we can run Julia -- project. So we're just going to do using FF Flamefied, and then we're just going to make sure it works. What windows are you using? It's fair point. That's how I learned Vim, so I get what you mean. Yeah, that's how, I think that's true for most programming things. You just have to use it. So let's just do points again. And then we're going to do image again and just make sure this whole thing works. And then I'm going to go ahead and commit what we have and force it onto our development branch. And I think that's actually, I'm not going to say that's a good place to stop for today, but I do need to take a break and do something else really quick. And I'm just going to do an algorithm archive PR. Maybe after the algorithm archive PR, we call it for the day. Because again, I have been streaming for about 3 hours now. And I'm doing everything I can to, bring my stream stamina back up, but take some time, So let's do the last mirage, check.png, and there we have our Serpenti triangle. Perfect. Okay, so now we're going to do get, what am I doing? Push, origin, development, force. Okay. Okay, so everything should be on the Flamify development branch if you want to go ahead and check it out. And yeah, we'll be continuing to work on this in the near future. But again, for now, I do need to take a quick break and do something else that is not fractals for just a bit. And I think we'll do some algorithm archive PRs, see what we can do there. Maybe there isn't much we can do, but I at least want to take a look at it. I don't think we can do a chapter. Maybe we do a chapter PR. I don't know. We'll see what we can do. So let's go over here. Let's go to the algorithm archive. And let's take a look at what we have. So Git repository here. Let's do pull requests. And let's see. So we have Cooley Tukey. Oh man. Make Euclidean algorithms NIM more idiomatic. I think this one, C252 says it looks good. So I think we'll do files changed. We'll do review changes, approve. C252 says it looks good. So I'm on board. Okay, let's go ahead and submit review there. And let's grab this one as well. So this will be a quick PR that we can merge, squash and merge, confirm squash and merge. Okay, that's the next one. Now, one thing you might have noticed here is that our Travis is down. Our CI is down. It's been down for a while and I don't know how to get back up. So we're gonna have to figure that out one day. Dart implementation of bubble sort, make nim more idiomatic. All of these are the make nim more idiomatic. So I'm just gonna take a look at these. Are there any languages you're specifically looking for the algorithm archive? We're not necessarily looking for more languages, but we are necessarily looking for more language reviewers. And I say this every time someone asks how they can help. Literally, we have 63 open pull requests. If you can just go here to this page, and if there is a language here that you know, if you know Lisp, if you know Racket, if you know any of these languages, and you can just look at them and just say, I can read this code, that's all I need. You don't have to comment on the actual algorithm. I can check the algorithm. I just need to know that this code looks like legitimate X language code. That's all I need. And we are fundamentally lacking in that for a lot of people. So that's what I would like. That's what we need, in my opinion. All right, let me get a little bit more water. Okay. Also, let me check something really quick. Yeah, that's what I thought. Okay, one second. I got a few notifications from work. Okay, that's that one. 1 second. Okay. Okay, let's just, yeah, okay, 1 second. I got, I'm not gonna, so people, I don't like notebooks. I think that they're a waste of time, and someone commented and they were like, oh, you know, I think you're just dumb because, anyway, we'll figure it out. I stuff to do for work, man. It's a day off. I don't want to deal with this. Anyway, okay. So for the nim more idiomatic, let me just go here. I think both of these can be merged. Yeah, I think following the same thing as before. I love to see coconut PRs that are not mine, but I think I did the easiest ones to implement. So that's probably true as well. I think these are fine. So let's just go ahead and say following 783, I believe these two can also be merged. Review changes, approve. Following, I think it was 783. This can also be merged. Thanks a bunch. Okay, approve that guy. Okay, squash and merge, confirm squash and merge, bam. Okay, that's 2 PRs done. That's pretty good. Okay, the last one over here, files changed. If result equals true for n, and I think this one's also fine. So let's just do review changes, approve, submit review, and let's go to squash and merge, confirm squash and merge. Yeah, I mean, my issue with notebooks is it's just too much. It's just too much. That's my problem with notebooks, right? Like, if you are trying to learn something, the only thing you need to learn that thing is the code and visualizations for the code, right? And notebooks are great, right? They give you, like, I just don't understand. Okay, here's what I don't understand. I'm sorry for the rant. I don't understand the problem that notebooks are trying to solve, right? Because look at the algorithm archive, right? Like, okay, here's what we do here. You do iterative function systems. You go down. Here's a visualization. Here's a visualization. Here's a visualization. We have videos embedded, right? So what does a notebook give you that this format doesn't give you, right? The only thing it gives you is the ability to run code in the notebook itself, right? So if you were given this particular chapter as a notebook, right? How does that help you? Okay, you can run the code, but also, like, does that actually help you learning what's happening? I would argue not really, because it costs a lot, right? Now you've got to wait for the notebook to compile. You've got to wait for it to run. There's so much that it costs to add that in there. I would argue it's better just to show them code snippets. And then also, because of the way the notebooks are written, it's sometimes hard to do things like, for example, we did in tree traversal, where we don't give you a full function. We just give you a little itty bit of the code, right? And so it ends up being hard, right? And then it makes it harder to write things. You literally just said the opposite, right? So I think notebooks are cumbersome because it's hard to write code in notebooks. Like in the terminal or an IDE, you just open up a page and you start typing, right? With notebooks, you have to create like, individual like blocks of code that all self-compile. It's for me, it's confusing. It's not how I naturally think about things. So basically, all things put together, notebooks are for me very cumbersome. I find that they aren't very good at teaching because, well, they're fine at teaching. I just feel like having a markdown page, just like we have in the algorithm archive, is better for teaching. And I don't really understand. I guess I don't learn very much from interactivity, right? So that might be why I don't understand the notebook so much. Like for me, what I need to do to understand code is just to look at the code and just underline it, be like, that's what this is saying. That's what this is saying. Okay, I understand what this is doing now. So that's where I'm unable to understand notebooks. I think notebooks could be useful if you do math and visualize math stuff. Maybe, right? So that's the thing, right? Like I do math and I visualize math stuff and I still don't find them useful, right? Like here's, Gaussian elimination, right? So, we have a visualization for Gaussian elimination, right? It's down here. But I don't know. I just feel like, I guess I don't mean to rant too much more about it. I'm not going to rant too much more about it. I just don't understand the utility in notebooks. That's all I'm going to say. I just don't understand it. Because to me, it's a lot of text for little code, and I need the code to understand. The whole thing's weird. I just don't get it. So it's just unintuitive for me. Now, does that mean that it is it's unintuitive for other people? No. Just because it's unintuitive for me doesn't mean it's not intuitive for other people. Other people can find it incredibly intuitive, and that's great. I just personally don't understand them. And that's where I stand with them. Now, again, if everyone in the world told me that notebooks are the most intuitive way to describe a topic, I would genuinely quit programming. Because, like, if we have to do notebooks for everything, it's so hard. Like, it's such a cumbersome thing. Anyway, I'm done with that. No more talking about notebooks. Okay. So we did 3 PRs. I think maybe this is a good place to wrap it up for today, actually, now that I think about it. So we have the ability, we have pixels, we have the ability to implement colors, we have this simple Sierpinski triangle visualization, we have the concept of iterative function systems. We've been streaming for 3.5 hours. I think this is a decent place to close for today. Tomorrow we'll come back and we'll actually do real fractal flames, not just like random iterative function systems, but like actual fractal flames. And we're going to get that working. We're going to do that tomorrow from 6 to 8 p.m. Eastern. And I think this is a good place to close for now. So let's see, who's live and who do we want to raid? We could do Dowright. Let's see, what's Dowright doing? Python, Internet, and Encryption. Let's see, Calo Creation, Lana Lux. How about we raid Lana Lux? That seems fun. So let's go and start that raid on Lana Lux, and we will go from there. For learning algorithms, it's not really worth it, I think. Yeah, anyway, I need to stop ranting about things. Like, for example, I rant too much about MATLAB and notebooks and things that I don't really care. If you like MATLAB, fine. If you like notebooks, fine. I don't care. If you like Emacs, fine. Like, it's not, I don't care, Like, I really don't. It's just that when I'm being pushed into using these things, like I'm being pushed into using notebooks, or I'm being pushed into using MATLAB, or I'm being pushed into doing things that I don't like, then I get frustrated, because now it's like, well, I didn't want to use this. I don't think it's useful. And now you're slowing down my workflow because you want me to use your tools, which are inferior. So it's like, I seem to start up the rant train about 50% of the time. No, look, for the record, you're not. I rant too much. I need to stop doing that. And I apologize. So, okay. Anyway, guys, I do think this is a good place to stop. The reason I'm ranting is just because I've been streaming for 3 hours and 30 minutes. And I get tired around this time. So I think this is the best place to stop. Okay, so we're going to raid Lana Lux. It's been a while since we raided her. She's really cool, game developer. So let's go start the raid on Lana Lux. And also, guys, please, I think that a lot of people probably come to the channel for the rants. So for the record, starting a rant is not a bad thing. In fact, I think it's quite a positive thing. It gets people talking about the appropriate ways in order to do software development, right? Because I've got very strong opinions. I'm sure other people in chat have very strong opinions. And by putting these opinions all together, you get a bit of anger, but presumably that anger, heats up the pot that you're boiling your software stew in and makes it tastier. I don't know, but you know what I'm trying to say here, right? Like, everyone has opinions, and it's important to know where I stand and where everyone else stands. And I think these rants are pretty useful. Anyway, guys, that is it for now. I'm going to go ahead and start the raid on Lana Lux. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. Should be at least at 6 o'clock p.m. tomorrow when we do some Fractal Flame stuff. I might start a little bit earlier. I'm going to start trying to start streaming at 5 o'clock so I can do 3 hours a day instead of 2 hours a day, and we can really start hammering out some cool code. And I'm going to start trying to do longer streams on weekends as well, just trying to buff up that stream stamina and stuff like that. I do appreciate it, guys, and I will see you next time. Bye, guys.